Yes, good evening. Good evening, everyone. Right. Just let us have the revision of the entire topic. Yes, very good evening. Very good evening. Right. See, I told you this point here. What is that? Plus or minus 1%, comma full scale value, or plus or minus 1%, comma reading. What is this error? This error is generally which error here? Percentage limiting error, I told you. Other than this, any one form, plus or minus 1%, comma full scale value, or just plus or minus 1%, or accuracy class 1.0, whatever will be the form, that error must be taken as percentage guaranteed accuracy error. This is one point I told you. And I told you day before yesterday, I told you GAE is given by manufacturer. GAE is given by manufacturer. What does it mean here? That means this will be decided by the manufacturer, not by the operator. People are asking on what basis, sir? All I told you, on what basis here? Full scale value basis, they will give the corresponding value. But in the operation, what we require? Percentage limiting error only. If the error is having more, if the instrument is having more error or less error, means we need to concentrate on percentage limiting error only. Why? Percentage limiting error is with respect to which value? True value. But in order to find out the percentage limiting error from the given data, they will give this guaranteed accuracy error. That's what the point. Clear? Point. And I have taken one more thing. Sir, multiplication or addition. Multiplication or division. Which type of errors we have to take? I told you. We have to take which value? Percentage form of errors we have to take. And addition and subtraction. Addition, subtraction. Which we have to take? Value form of error. In the given question, 2-3 steps may be there or single step may be there. Don't get stuck up. Simply multiplication and division is there. We require percentage form of errors. Addition and subtraction is there. We require value form of errors. And we have seen so many questions, right? Right. I told you already. See here, accuracy. Kindly before sending the question, read that question once, go to that question once, and then only kindly accurate Tarun. Sir, stop your face cam, sir. Why? Why accurate Tarun? Right. See here. Sir, I told you clearly. Suppose if the statement is given like accuracy plus or minus 98%. In this, the word error or true value present, etc. is not given. Is not given. Yes or no? So therefore, here our accuracy 98% of something is given. What does it mean? Sir, plus or minus is there. Therefore, error. Therefore, error 98%. Okay. Again, people are asking that, sir, plus or minus is not. Come on here, I gave the word, no here. I gave the word error. If error word is given, why are you getting worried like error or not? Already I gave the error. Already I gave the error. Clear? Right? So that's why. Here also. Sir, plus or minus is not given. So what does it mean? Error is, how much here? 2%. If I write the word as error, no second thought, that will be error only. That will be error only. One student is asking that, sir, in accuracy terminology, when accuracy is plus or minus 98%, can we take error as plus or minus 98 or only 98? Try to understand the terminology. Try to understand terminology. If error is there, no need to indicate. No need to indicate. If you want to indicate, you can indicate like this. Okay, he has given plus or minus. Actually, you should not get this question here. Error without plus or minus will not be, because error either positive or negative. In the question itself, answer is there. Sir, error can be treated as plus or minus 98% or just 98 means. Question is there. Go to the starting day, first day class. Error is either positive or negative. If you go to that notes, kindly don't ask these questions. Okay. Right. Okay, see, if my video is coming in the middle, you have the option here, kindly move it to some other side. If that is also a problem, I can't do anything, right? Right. So people are saying that in the PDF terminology is missing. I will check it once. Right. See, if accuracy word is, I'm repeatedly saying accuracy word, if after this value, if no name is given, that is GE only. Repeatedly I'm saying that if only reading is there, that is percentile limping error. Otherwise, according to the given terminology, you have to consider that as GAE only. Right? And kindly, if you don't know the English, kindly don't send that question. Right? Sir, I'm not understanding this meaning. That is also I should answer, but it's very difficult. Go open the dictionary and see that word and solve it. Sir, I don't understand this word. I can't do anything. Clear? Right. Now let us continue the topic. Right. Yes. Okay, now let us talk about the linearity topic. We are discussing about linearity. I gave the simple idea what is linear and what is non-linear. I gave you. Now I'm taking non-linear system. Right, non-linear. Sir, what is non-linear? I told you, if any system is zigzagly, randomly increasing, decreasing, etc., that system is called as non-linear system. Okay, right. So this is the characteristic. All I told you. This is output and this is input. Right. Okay. Now, what is non-linear system? All I told you. Suppose if you want to get the non-linear system, yes, I'm taking ideal system as the reference value. Okay, so this is ideally linear system. Ideal linear system means I'm expecting a linear. So expecting means ideal. That's it. Whatever may be the system, if you are expecting 100% perfect, that is simply ideal system. Right? Okay. Now, so here, suppose if the non-linear system is like this, for example, something is exactly I'm taking. Sir, in this system, how much is the percentage non-linearity available? It is non-linear. Why? Simply input is increasing, output is decreasing, increasing, randomly changing, and the two suddenly increasing, suddenly decreasing, etc. is there. So that's why. How do we define non-linearity? How do we define the non-linearity term here? Concentrate here. The percentage non-linearity. Here, percentage non-linearity. This is the definition. Kindly concentrate. The percentage non-linearity is given as concentrate. Sir, this is the definition. Kindly concentrate. Percentage means into 100, right? Sir, maximum deviation maximum deviation of obtained line, maximum deviation of obtained line from ideal line, maximum deviation of obtained line from ideal line with respect to the true value. This is the definition. What is the definition, guys? The percentage non-linearity can be defined as the ratio of maximum deviation of obtained line from ideal line to the true value of the corresponding system. Or one more definition also there. Two ways we can express. So what is it? Numerator is same. Numerator is same. I'm keeping like details like this, means only numerator. But denominator we can express as the full scale value also, means according to the given question. If he is asking express with respect to true value, use this formula. Express with respect to full scale value, use this formula. So what does it mean actually? Be clear. Percentage non-linearity means, is it unwanted or wanted characteristic? Means unwanted only, because we want always linear nature. But if it is non-linear, means generally unwanted. Unwanted means error related terminology. Okay, sir. Maximum, keep it aside. Maximum, keep it aside. Sir, deviation means minus. Obtained value means measured value, we can say. And ideal means true value. AM minus it. Indirectly, what is a numerator terminology here? AM minus 80 only. But we should not say AM minus 80 because it is not the value based, it is the characteristics based. So that's why we should say line to line concept. Value to value concept is normal error terminology, but line to line concept is, yes, in the linear and non-linear system. That's why after that, sir, by, we have studied two terminologies. By 80 we can take, by full scale values we can take. In the same way, the deviation of the corresponding obtained line by the obtained line to the ideal line expressed as a true value, one definition is there. As a full scale value, both are acceptable. But in the question, whatever he is asking, that you need to concentrate, that you need to take it properly. This is the definition of the non-linearity, or we can say into 100 means percentage non-linearity. Clear, guys? Right. Now, so in this graph, where is that maximum deviation? Where is that maximum deviation? Concentrate. Sir, at this point, right? Suppose at this point, you're expecting this, but you're obtaining this. Now, can I say in this graph, this much of change is, or this much of deviation is maximum deviation? Can we say or not? Yes, because other than this, you take any point of the corresponding obtained line, everything is less than this deviation only. How? Check it here simply. Sir, at this point, for example, expected obtained, this gap is less than this gap only. Means this deviation is less than this deviation only. Next, here, at this, here and here, this deviation is less than this one. Like that, if you take the throughout the journey, whatever the waveform is given, first find out the maximum difference from obtained to ideal at a given particular value. Here, this is the value in my picture. So therefore, this I'm writing as maximum deviation. Maximum deviation. Clear? Right. Okay, sir. In order to understand this topic more and more clear, I'm taking one numerical question so that it will be clear. Concept is over, but I'm giving the non-linearity question value. How to get it? Concentrate here. Right. Kindly concentrate. Few people ask this question. Come on here. Topic is not done. How can you ask the doubt? So that's why whatever we have done, kindly solve those only. Whatever I'm going to take in the next class or coming class, etc. Kindly don't get confused with all those things. Clear? Right. So see, an ammeter has a range of 0 to 30. Okay. What is it? Full scale value is 30 amperes. Okay. The instrument gave the following readings. These are the readings given by the instrument. Sir, current flow is 0. Ammeter reading is 1. Current flow is 5. Ammeter readings like that. Different values are given. The first question in this here is, sir, which is the true value and which is the measured value? Means, sir, current flow. Current flow means which value? True value means actually the current is flowing through the device. And ammeter reading means AM. Okay, okay. The non-linearity of the instrument in terms of, be clear guys, the non-linearity of the instrument in terms of full scale reading, that is percentage of full scale value. He is asking, what is our duty? We need to find out maximum deviation of obtained. Obtained means measured from the true value. Okay, check it here. Sir, 0 and 1. What is the gap? What is the deviation? 1. Okay. 5 and 4. Deviation only. Sign, no need to worry. 10 to 12. 2 is the deviation. 15 to 14. 1 is the deviation. 2 is the deviation. 3 is the deviation. Sir, which is the required value? Yes, this is the required value. Why? Maximum deviation in the operation is 3 according to the given data. So therefore, that you have to mention that. First, what is that? Maximum deviation. Maximum deviation is how much here? 3. Current, no, ampere. Okay, simply. What is the answer? Percentage non-linearity. Percentage non-linearity equal to maximum deviation by full scale value 30 into 100. So answer is 10%. This is what the answer in this question. Clear? But I'm adding some more question. I'm adding some other data for this. Sir, what is it? In the question I'm giving. In the previous question, find the percentage non-linearity. Find the percentage non-linearity in terms of true value. In terms of true value. Everyone gave the answer for earlier question 10% like that. Now I'm asking with respect to true value. Likita, I have not neglected the sign. Simply in the options, he will not give the sign, no need to worry. Because knowledge may be either plus or minus side will be there. No need to worry about the sign in the non-linearity. Clear? If you want to mention, you can mention, nothing wrong, no problem. Right. Yes, many people give the answer. Correct. Right. Sir, first of all, check it here. Sir, maximum deviation is 3 as usual. Maximum deviation is 3. Okay, right. Sir, in this, maximum deviation occurs at which true value? Maximum deviation occurs at which true value? So 25. By getting confused, people are taking that 28 here. That's why I told you 80 is this, AM is this. 28 is not 80, 28 is AM. So that's why 25. So therefore, simply, what is it? Percentage non-linearity equal to 3 by 25 into 100. So therefore, what is the answer? 12%. In the examination, anything may be given. Anything may be given. Either this question or this question or combination question also they may be asking. Right. Madhumita, is it 10.71? How? Kindly verify. That's why I told you it is not 28. If you take 28, that may be there. But here, sorry, it is not 28. If you take 28, that may be there because 25 is the true value. This is the true value. This is not the true value. Concentrate. I got it? Right. Let me take one more question. In this, two questions I'm giving directly. Two questions. Chaitanya Kumar, first take what I told. After that, I'll clarify your doubts. Before taking only, you're getting so many questions. First, take it as it is. Wherever you are getting the maximum deviation, that you have to concentrate. That true value, you have to take it. Where you are getting the maximum deviation, that true value, you have to take it. Right. 90%, 88%. Tirupati Reddy Ambati. Why that much high value you are getting? Right. First of all, sir, this is the full scale value. Okay, right. Sir, current flow means true value. And ammeter reading means measured value. Okay, right. I'm writing for just clarity purpose. I'm writing here difference is 2, here 1, here 2, here 1, here 1, here 5. So I'm circling this 5. What is the maximum deviation? 5. Clear? Right. Let me solve now. So maximum deviation is 5 because 40 and 5. So 45 means 5. And first one, what is asking with respect to the full scale value. So therefore, percentage non-linearity equal to 5 by, what is the full scale value? 50. 50 into 100. So what is the value? 10%. Okay, right. Second one, percentage non-linearity is equal to, what is that? With respect to true value. At which true value you are having this value, right? Current flow 40. So therefore simply 5 by 40 into 100. 500 by 40. How much will be there? Yes, 12.5%. These two are the values in the question. Clear? Now I'll clarify all the doubts. First, you take it first. What I'm explaining, first you receive that. After that, if this is already told you, whatever the thing I'm giving, you take that first. So if this is not there, that is there, I'll tell you. That is my duty, I will tell you. But first, if this is there, what will happen? You take it first. Without taking that, this is not there, that is there, something else will be there. Don't waste the time like that. Okay? Right. Now, I'm clarifying all sorts out. This is a general doubt to any student. General doubt. Sir, suppose if the values are given like this. Sir, 5 is there 4, 0 is there 1, for example. 6 is, so 10 is there 12, 15 is there 17, right? 20, 21, 25, 26 is there, for example. For example, if you are having the data like this, don't worry, they will give the clear cut data. Kindly concentrate. First, try to get the things. After that, if this is not there, that is not there, something is there, something else is there, we'll be taking later everyone. Here, difference is 1, difference is 1, 1, 2, 2, 1, 1. Sir, if this is the data available, how do we take it? Means don't worry, they will ask the question clearly that find the percentage non-linearity with respect to true values, with respect to true values. They will ask with respect to true values. In the options, 2%, two answers will be there. With respect to true values, so two answers will be there. Where are you getting tense? They will ask the question clearly. Okay, so that with respect to which one, this is true, for example, this is measured, for example. People's doubt is, sir, 2 is there, 2 is there, both the cases maximum is there. Yes, you need to take this as the first question, this as the second question. They will give two options, don't worry. So clarity will be there in the question, no need to worry. Suppose, sir, if the thing is not given like this, if the thing is not given like this, sir, in the options only one thing is there. People are coming the reverse way. That's why before you ask, I'm saying, sir, in the examination, only one answer is there. Then which must be taken? Then he will give the question like percentage non-linearity with respect to the true value of 10 ampere. Like that they will ask. Otherwise, true value of 15 ampere, they will ask the question clearly. Don't worry. That's why first one is there, no, only one place maximum, you take it first. After that, immediately before taking that, so two place it is there, precision we have to take, average. Who told all those things? Who told you to take all those? Kindly wait, I will give you a bit. That's why if you are having hurry-burry mood, I cannot answer your questions properly because other people will get disturbed. That's why the way of getting the subject is whatever the faculty is explaining, take that first. After that, after completion of that, if something else is there, that is there, this is there, you ask that later. The moment I'm doing this, people are asking, sir, that is what this point. I will explain where, I will explain definitely. Without explanation, I will not go. No need to worry. Clear? Clear, guys? Right. Other than what I told you, other things you are getting something into mind like precision we have to take, average you have to take, whichever is maximum, all those things are wrong only. In this way, they will give you, don't worry. Clear? So this is the total discussion regarding linearity as well as non-linearity. Clear, guys? Right. Now, only concept you have taken, linear concept and non-linear concept you have taken. Now, slowly I'm entering into instrument. What is that? Linear scale instrument. Now, definitely many doubts will be there. Kindly let me explain. Then you will not get any doubt. But while I'm explaining, if you are asking the doubt will be continued. That's why let me explain. Now I'm entering into the instrument topic slowly. I'm entering into instrument topic. Right? Now, linear scale instrument means how the scale will be. And non-linear scale instrument. Non-linear scale instrument. How the scale will be. How the scale looks like. Very, very simple. Sir, take the instrument. Take some instrument. Our topic is electrical only. Yes, electrical instrument. Right? Take the scale. Right? 0. Right? Now be clear. Linear scale means uniformly distributed divisions will be there. Uniformly distributed divisions will be there, plus 2, 4, 6, 8, 10, 12, like that. Uniformly distributed scale divisions will be there. That type of scale is called as which scale here? Linear scale. Linear scale other name is uniform scale. Linear scale other name is uniform scale. Simply uniformly distributed scale divisions are there. That is called as linear scale. right? Clear? Right. Next. Non-linear scale means 0. Okay, right. So some gap is there, some gap we don't know. Suppose if the values are like this, 5. Next division is 6, for example, randomly. Next division may be 9. I don't know, some numbers I'm taking. 15, 21, 25. Now tell me, is this device having uniformly distributed scale or non-uniformly distributed scale? Means non-uniformly distributed, non-uniform, nothing but simply non-linear scale. Non-linear or non-uniform scale, we can say. Clear? So this is the scale representation. That's why by looking at the scale, how can you say which is linear, which is non-linear? Means simply uniformly distributed scale divisions are there. Those are linear scale devices. Those are having non-uniformly distributed, zigzagly, randomly, anything. Uniform division will not be there. That is called as non-linear scale. So therefore, based on the nature, we are going to the corresponding scale. But very, very, very important task here is, sir, y proportional to x scale is there. Y proportional to x scale is there. Is it linear scale or non-linear scale? Means y proportional to x means automatically which one here? Linear scale. Nothing but uniform scale. Linear scale, nothing but uniform scale. Already we have taken, yes, what about linear and all? We have taken already. Yes, I'm drawing the same figure here. 0, uniformly distributed divisions will be there. Right? Now, here, like this. Sir, if I write 5, 10, 15, 20, 25, 30, is it uniform or non-uniform? Definitely uniform only. So therefore, what's the point now? Yes, uniformly distributed division values also. Yes, this is uniform scale. Okay. Clear? Right. Now, the second point, I'll come back to that later. Sir, in this second one, sir, y proportional to x square scale. So what is y proportional to x square? Is it linear scale or non-linear scale? Y proportional to x square. Is it linear scale or non-linear scale? Urukonda Satish, what is our topic? What are you typing? What is our topic, Urukonda Satish? If this is the case, kindly don't disturb me. Don't disturb me. Right, sir. Which scale? Non-linear scale. Nothing but non-uniform scale. Okay, but sir, it is non-linear, okay? Non-uniform is also okay. But my question is, sir, is it randomly changing? Is it zigzagly changing? Or with one relation it is changing? Means with one relation it is changing. Which relation? Parabolic relation. Which law? Square. That's why one more name is square law scale. One more name is square law scale. Now, just for clarity purpose, I'm asking one question. Concentrate. Sir, all non-linear scales are square law scales. True or false? All non-linear scales are square law scales. True or false? Yes, very good, very good, very good. Yes, false. Everybody has given correct answer. Very good. Why means all non-linear scales means in the non-linearity, sine wave may be there, cosine wave may be there, cube law, Powerian law, any law may be there. But it is all R square law wrong. Second one, all square law scales are non-linear scales. True or false? Now this statement, true or false? All square law scales are non-linear scales. Right? True. Why? Square law itself is coming under non-linear nature. Therefore, all square law scales are non-linear scales. True. That's why try to identify the difference between square law scale and non-linear scale. Now tell me, sir, this is non-linear, but can we say this law as a square law scale? It is a non-linear scale, but can we say it is a square law scale? No, it is just non-linear. Okay, zigzag, randomly something changing. But now we need to draw. Now we need to draw square law scale. How will it be? Concentrate. So how do we draw square law scale? How do we draw square law scale? Very, very, very important task. After this, I'm going to give one more conclusion also. This is 0, some full scale value, some value, don't know. Right, sir, how do we get this? How do we get this? Very, very simple. Yeah, sir, here y proportional to x square is our topic. Okay, here I'm writing y versus x values. Okay, right, sir, x is 0, y is 0, x is 1, 1 square 1, x is 2, 2 square 4, 3, 9, like this. Keep on taking 9, 81, 10, 100. Right now, by seeing this, kindly consider. Sir, x is changing 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, like that normally. But the y value is changing. In which notation? Square of the x. Square of the x, it is changing. So therefore, my question is, sir, 0 to 1. Come on, guys. 0 to 1. How much gap is there? 0 to 1. How much gap here? 1. 1 to 4. 3 gap means 3 units jump. 4 to 9. 5 units jump. 9 to 16, 7 units jump. 16 to 25, 9, like that. If it is keep on going here, 81 to 100, 19 units you can say. So therefore, what is the nature of the square law? You know, here, crowded at the beginning. This is what the technical statement. Crowded at the beginning means very close, 0 to 1, small change. After that, 1 to 4, 3 change. 4 to 9, 5 change, means crowded at the beginning. Crowd means very close at the beginning and spreading towards the full scale value. What is that? Very close at the time of starting, origin. But if you're going towards a full scale value, higher value, what is that? Gap is keep on getting increased. That is the nature of the square law scale. That's why, how can we draw the scale? Concentrate here. Sir, during the 0, right, very close lines will be like this, very close. After that, gap is increased. After that, further gap is increased. Again, increase. Again, increase again. So this type of scale is called a scale here, square law scale. This is not by blind logic. This is by purely concept of square law scale, concept of square principle I'm taking. Crowded at the beginning, I'm coming again, crowded at the beginning and spread out towards the full scale value. Yes, crowded at the beginning, spread out like that. Keep on going, the gap will be keep on getting increased. This type of scale is called as square law scale, comes under non-linear category. Okay, right, sir. Very, very important point here is concept. These are purely parabolic operation concept. Sir, where do we get less error in the operation practically? Suppose if you are operating towards this region or towards middle or towards full scale value, where do we get better result or less error result? Means concentrate. Sir, let us draw the parabolic system first. In your entire engineering subject, whatever the subject you take, if any parabolic system is there, like this, if you want to draw a tangent, if you want to draw a tangent, where do you draw? If you want to draw a tangent, where do you draw? Right? Always we draw the tangent with respect to which one? Center portion. Means in the parabola, if you observe clearly, concentrate. Suppose this is input, this is output logic, for example. So here, this input is increased by large value, output is increased by small value. Okay, right. Sir, if you are coming this side, input is increased by small value, output is increased by large value. Are you clear? That's why if you come in the middle portion, from here to here, approximately, not exactly, approximately. Now tell me, input and output almost same or not exactly, almost same or not? That's why almost same. That's why what we do know, missions, especially electrical people, IN people, missions, first time you are going to study, we'll be taking that later. But IN people, electrical people already know. What is that? Draw the tangent in the linear portion of the curve. Already it is a curved portion. Where do you get linear means? That means approximately linear, not exactly, approximately linear. Which portion? Means middle of the portion, middle. That's why I'm highlighting this one. So this portion is generally treated as, concentrate here. Let me complete, then you ask this doubt here. This portion is approximately linear. Though no one should question like, so how can you treat linear? I'm treating as approximately linear, because here large input, small output change. Here small input change, large output means suddenly changing. But in the middle of the portion, approximately linear means what is that? Input output changes approximately same, not exactly, approximately same. Now tell me, which region of operation gives better result? Means this is experimentally proved. Concentrate. The experimentally proved here is approximately linear region is to be operated as, what is it? Taken as operating region. Sir, what do you mean by operating region? Again, people are getting confused here. Sir, operating region means we should operate in this only. We should not operate. Not like that. Not like that. If we operate in this region means neither crowded, means neither starting nor spreaded, means nor final side portion. In the middle of the portion, if you operate in the middle of the portion, if you operate, that device will give less error comparatively by the concept I told you, and also by experimentally it is proved. So therefore, in the square law scale type of design, square law scale related structures or instruments must be operated in which region? Means approximately linear region must be taken as operating region. This is a parabolic concept. This approximately linear region is which one? In this, you can check it here, sir. Very close divisions, very far, but these are not too close, not too far, means approximately in the middle portion. That's why the middle portion must be taken as the operating region, where we get less amount of error. Conceptual, I told you, I'm repeating, and also experimental also proved. One thing. Second thing, sir, come back to this, sir. Non-linear portion is okay, but what about linear then? Linear scale is there. Which region must be taken? Means in the starting day only, in the yesterday only, in the day before yesterday, in both the days. I told you, what is it? The percentage limiting error is getting reduced towards the full scale value. I told you, no. But when I was taking the topic yesterday or day before yesterday, did I take any linear, non-linear word? No. Why? We were not knowing what was linear and what was non-linear at that time. That's why be clear here. If the scale is not mentioned in the question, concentrate. If the scale nature is not mentioned in the question, everyone remember, you should treat that as linear scale only. If he mentioned like square law, cube law, sine law, logarithmic law, then you take it. If the scale is not mentioned, you should take that as which law? What is it? Linear scale only. That's why in the linear scale type of devices, already we have taken in the yesterday's class and day before yesterday. What is that? Simply in these type of design instruments, operating region is which one? Towards full scale value. Towards full scale. That's what the point. So this is the total scale. But This point already I told you with examples in the yesterday's and day before yesterday's class. Okay, but there I did not mention scale because we don't know. That's why if scale is not given, all the general laws must be taken as which one? Linear scale only. But if they are giving that square law based statement, y proportional to x square law, yes, you need to take the middle portion, or in the parabola approximately linear portion is to be treated as operating region. Clear? But concentrate. In order to understand this, I'm taking one question. With that question, you will get more clarity. What is it? Let me take now. Sir, here, for every topic, immediately I'm giving one question also to understand. But I cannot help to 2-3 people because while I'm explaining, people are typing 2-3 lines of question. 2-3 lines you're typing means definitely you're missing 2 to 3 minutes of topic. I cannot help you at all if you miss the topic. No one can help you. That's why don't type means don't type only. But people are asking 2-3 lines of question they are typing. You will be the loser. You will be the loser. Right. Now, here, sir, after taking the question, I'll come back again. Sir, here, for 17 amperes of current measurement, for 17 amperes current measurement, don't get confused with the question like, sir, 17 already given, no, why are you not like that? If I want to measure 17 amperes of current properly, perfectly, means with less possible error, what we have to prefer? That's what the question. I'm giving 3 devices to you. 0 to 20 ampere, 0 to 30 ampere, 0 to 100 ampere ammeters are given. These are the ammeters. Okay, right. Now the question is, sir, when these ammeters are off, PMMC type. Sorry, you did not say. I'll tell you. Second one, moving iron MI type instrument. What do you mean with that? You're having 6 devices. PMMC type, these 3. MI type, these 3. Totally 6 devices are given to you. Means 2 different operations. How much current you want to measure? 17 amperes. But see, which device you prefer? That's what the question. Sir, in order to answer this question, you need to understand what is PMMC, what is MI. I'm going back. I told you, I'll come back here. Whatever the scale is there, which scale, square law scale is there, that is available in moving iron instrument. After this chapter and next chapter, instruments will be there. That is PMMC, MI we are going to study. I will prove completely with the mathematics why the MI instrument is having square law scale. I'll prove it. Complete concept is there. No need to worry. Next, sir, linear scale will be available in which device? Yeah? PMMC type of device. So that's why in this question, what does it mean? PMMC means indirectly he is giving the question like which one? Yeah, linear. Indirectly he is giving the question like linear scale. And other thing is nothing but it's simply non-linear scale is given. Clear? Right. Sir, Sri Charan, is it AC or DC? No need to worry. Normal instrument based operation will take about later based on AC or DC. This is the question only based on scale. This is the question only based on scale. I'm repeating, only based on the scale. Right? That's why, okay, you don't understand my statement. That's your wish. No one will help you. Whatever the thing I'm giving, take that only. I told you. If that is not there, this is not there, still you're asking, still you people are asking. So no one will help you. That's your wish. Okay. Now, I want to give the 100% subject perfectly. Let me give. I'm requesting everyone. I'm here to give the 100% subject. Those who attended my class earlier, last year, etc., they know about my explanation. So let me explain. But 2-3 people are not allowing me to explain at all. They are trying to disturb me completely, intentionally, it seems. Right? Few people, I don't want to mention their name, but few people are doing like that. You will be the loser. right? Okay. But other people, don't worry. I'm here. I'll explain the things properly. Follow me step by step. Tomorrow, what will happen? We'll see tomorrow. After 1 hour, what will happen? We'll see after 1 hour. Don't worry. Kindly follow me. You will get the subject, right? Other people, intentionally you are doing means no one can do. No one can help you, right? Okay. Now, sir, PMMC type and MI type, right? Okay, sir. PMMC means immediately you should get the point, like, okay, PMC means linear scale. Okay, right? But randomly, I'm drawing the simple scales like this. 3 devices I'm showing. 0, 0, 0, 20, 30, 100. In the same way, 0 to 20, 0 to 30, 0 to 100. These type of devices are there. Very simple, very simple. Sir, here, sir, 0 to 20 scale, where will be the 17? Close to 20 or middle or close to 0? 17 is close to 20, definitely. Yes, here it may be there. 0 to 30, our 17 amperes will be approximately half. 30 half means 15, no? Yes, approximately here. Okay, 0 to 100, but our topic is 17 only. Yes, close to this. Are you clear here? If you're writing 0 to 100 like that, if you're taking 0 to 100 this way, 17 is close to 0. And 17 is middle of the scale. 17 is close to 20. This is what the thing. In the same way, sir, 17 is here, 17 is here, and 17 is here. Now, what I told you, linear scale operating region is towards the full scale value. Yes, PMMC linear scale operating region is towards the full scale, means towards the 0. More error. Error is less. Here error is further less. So therefore, which device we prefer means 0 to 20 ampere device we prefer when the PMMC type of devices are there with us. Next, second point. Sir, here 0, it is close to 0 means this is in the crowded region. This is close to 20 means this is in the spreaded region, but this is in the middle of the region, which is called operating region. Go back and check it. Sir, middle of the region is operating. So therefore, which device we prefer here? 0 to 30. This is what the actual topic related to. Linearity, non-linearity. In that non-linearity again, linear scale, non-linear scale. In that non-linear again, square law scale, combination question. So this is the way of answering the questions. Clear? Now all types of doubts will be clarified. Yeah, Dinesh, yeah, I'm doing that only. Thank you. Right, very good. That's why, let me explain. Once I say the topic is over, definitely you will understand. That is my guarantee, no need to worry. But if you type in between, definitely you did not understand. You will not understand, definitely. Right. See, AC, DC, as of now, we don't know. AC, DC related thing, anything we don't know. We are going to see that later. We are going to see that later. Right? Okay. See, I have not drawn the diagrams at all, but people are saying that, sir, both diagrams are looking like same. See, I have not taken the total scale. MI means you need to observe this type of scale is there. 17 is coming over here, 17 is coming over here, 17 is coming over here. Both diagrams are looking like same means I cannot do anything. Both diagrams are not same because this is square law scale, this is linear scale. I have not written all the scales 1, 2, 3, 4 like that. How many times I have to write here? So try to understand the concept. Clear? So this is the total discussion regarding linear as well as non-linear scale. Right. And one more question. Yes, good question, sir. Do we take this type of approximation in all types of non-linearity? How can you take parabolic approximation for something else? In your question itself, answer is there. This is the approximation in the parabolic system. In the parabolic system means that is square law. Square law means square law only you have to take. How can you take for something else? That is one point. Second thing, in our entire measurement, I'm repeating, in our entire measurement, we have only two types of scale devices. One is linear, one is square law scales only. That's why don't worry about the other type of scales. In the measurement, we're having only these two. One is linear and one is square law scale type of devices. Though that's why I'm talking about this only. One student is asking that, see, sir, y proportional to x square parabola, can I use the same formula for hyperbola? Like that you're asking. Can I use the same formula for hyperbola? We cannot. Same thing. Yes, whatever the notations, assumptions, technicalities you have taken for square law, those are applicable only for square law, not for something else. Not for something else. Clear? Right. Again, I'm repeating this point. I'm going, sir. In the question, how do we know square law and linear? What are you doing here? What are you doing? I'm explaining. Already gave you PMMC, linear, is or no? And MI. Here, MI instrument, square law already told you. After saying that only, I have taken the question. Clear? In the question, PMMC means already gave you know here. PMMC, not linear scale, already told you. And which one? MI. MI is non-linear scale, already told you. After saying that only, I have gone to the question. So kindly concentrate. Right? Okay. So this is the total discussion regarding linearity versus non-linearity. Total concept I have taken. And then scales, in the scales also corresponding numerical question. Clear, guys? Can you respond? Topic is clear? Right. KL like a click, I think your name. Why MI is non-linear? Already told you. Already told you. Here, non-linear YMI, I will explain later. Still you are asking, means intentionally you want to disturb me. No, I'm mentioning like this so that you can be quiet from next time onwards. Okay, right. Next one. So next topic is sensitivity. Sensitivity. Right, sir. In this also, concept is there, numerical questions, and so many previous paper question models also there. Be clear. Sir, what do you mean by sensitivity? Here, especially electrical people are getting confused because electrical people are aware of sensitivity and as well as melting point, like the confusion is. That's why kindly focus more on this. Sensitivity means responding for smaller values, responding for not the larger values, responding for smaller values. Clear? Right? So responding for smaller values, then that system has the characteristic called as sensitivity. Okay, right. So therefore, here, the basic definition of sensitivity is delta output by delta input. Very, very simple definition is this. Delta output by delta input. What does it mean? Concentrate. Sir, if there is a small change in the input given to the device, then automatically instrument pointer also correspondingly should be responded. Then that instrument is called as high sensitive instrument. Okay, second thing. If I'm giving small input change to the device, but the pointer is not responding properly, then that instrument is called as low sensitive, less sensitivity, we can say. That's what it means. Always sensitivity means high sensitivity means responding for low values. Responding for low values. See, if any system is responding for as small as possible values, then that instrument or that system or that structure is called as having high sensitivity. And definition is small change in output by small change in input. Okay, very simple. Suppose one instrument is there. It is showing some value, some x value. Okay, x is there, x. Ideally, I'm taking. If I'm changing this x to x 0.001, for example, even for this small change, if the instrument pointer is properly responding, then that is called as high sensitivity. Otherwise, we can say low sensitivity. That's what the topic. Okay, right. So, concentrate, sir. Everyone, what is the unit of sensitivity? Now it's time to answer. You answer. What is the unit of sensitivity? Unitless, no unit, unitless, no unit. Okay. One student gave the correct answer. Other people are giving unitless and no unit, unitless and no unit. Right. Be clear. Okay, okay. No problem. Every time many people give the same answer, like no units, they will give. Simple logic. I'm giving now. Listen carefully. Suppose I'm taking one instrument. Right? What is this? Ammeter I'm taking. Like this. This is the pointer. I'm giving 4 amperes, for example. So it is showing this value. Let me take approximately 4. Okay, thing is done. Now I'm adding 0.1 ampere. What is the input change I have given? What is the input change I have given? Current. So therefore, delta I. What is it? Input change. What am I observing? Pointer movement means like this. Yes, due to small current, the pointer deflection is like this. So what you observe here? Delta theta. Angle of deflection of the pointer, delta theta. Delta theta. Now can you say no unit here? See, that is what the problem I told you, electrical people. See, output power by input power efficiency, no unit. That was power by power efficiency. But this is not power by power here. Simply input, what we have given. Output, what we are observing. Input, what we have given. Output, what we are observing. Same type of topic will be there in your control systems also. That's why sensitivity is not with respect to output of the system and input. No, sensitivity is with respect to what change we are making, what change we are observing. Here, what I'm observing, change is current, change observed is theta. So therefore, what is that? Radians per amperes. Unit is there or not? Yes. Suppose I'm taking it as a voltmeter. I'm taking voltage. Voltmeter means 5 volt is given. Okay, right. After that, I'm adding some 0.2 volt something. What is the change in input here given? V. So delta V. What is the output we're observing? Deflection of the pointer. So therefore, delta theta. So therefore, what is it here? Radians per volt or degrees per volt. That's why always be clear. The sensitivity unit depends on input and output. Depends on what input you are changing, what output you are observing, what output you want to observe, what output you require. That's why it depends on the corresponding input and output in the corresponding content. That's why it depends on the given data. Which type of operation we don't know. I may be using ammeter, you may be using voltmeter, something else will be there. Okay, one point, very, very important point. Second thing, this is only for idea purpose I'm giving. The sensitivity is also called as, other name, sensitivity is also called as figure of merit. Generally, in the electronics language, in the electronics logic families like that will be there. In those topics, generally, they use figure of merit. Nothing but we can say, this is the electronic based terminology. This is the electrical based terminology. Both are same. Sensitivity or figure of merit, both will be same. I'm repeating, sensitivity, other name is figure of merit, but application is generally in the electronics language, figure of merit, sensitivity in the electrical. But you can use both anytime, no problem. Logic families will be there in the EC branch actually. Logic from TTL family, ECL family, E square A, like that. So many families will be there. In those logic families, instead of using sensitivity, they will use the word as figure of it, but both are same only. Both are one and only same. This is the complete explanation regarding sensitivity definition and corresponding concept. And one more formula is also there in general. In general, right? Sensitivity is defined as reciprocal of what is it? IFSD. Sensitivity in general defined as reciprocal of IFSD. Now, the moment I'm writing this, people are getting doubt generally. So, which is correct? Both are correct. This is when experimental analysis is given. Experimental analysis. This is the change I made. This is the change I observed. Like that. Experimental analysis is given. This is you to use. If instrument data is given, you have to use this formula. What is it? Sensitivity is equal to 1 by IFSD. Okay. Now, if this type of data is given in the question, in this context, what is the unit? 1 by ampere, 1 by volt per ohm, nothing but ohm per volt. So therefore, sensitivity unit is ohm per volt in general. Sensitivity unit is depending on the input what we are changing, output what we are observing. That is experimental analysis. But immediately don't get the question like, sir, in the examination, what is unit of sensitivity is given? What we have to answer? See the options. See the options. According to the given options, you need to answer. The two in the last year only, GATE 2021 paper, MSQ, multiple select questions are given. Multiple select questions are given. What do you mean by that here? A, B, C, D. 4 options will be given. A is correct, tick it. C is also correct, tick it. B and D may be wrong. So that's why multiple options are correct. Those type of questions are called as multiple select questions. This is recently added last year by IIT Bombay. So it will be continued. So in those questions, if they are asking like unit of sensitivity, means first option, no unit. Wrong, definitely. Second option, depends on input and output required. Third option, ohm per volt. Right, correct. Right? Second is correct. Third is also. Fourth is something else is good. Like that. For example, second and third, both are in that. You have to select it. That's why both are correct only, but depends on the context what we are taking, experimental analysis or instrument based. Okay, after that. Sir, one more continuation point is inverse sensitivity. Inverse sensitivity, or it is also called as deflection factor. Inverse sensitivity are also called as deflection factor. Right. It's very simple. Once you know the sensitivity, inverse sensitivity is very simple. What is it? Here, 1 by S. Inverse means what? 1 by S. This deflection factor, inverse sensitivity, is denoted with D. Right? 1 by S. Sir, what is 1 by S formula? Delta input by delta output, or simply 1 by IFSD means simply IFSD. This is the total concept regarding sensitivity. But here, generally people are getting small doubt. Come on. They will not mention so and so question is MSQ. Come on, this is a GATE exam. They will not mention this is MSQ, this is MCQ like that. No, you should understand. That's why after reading the question, right, without reading the 4 options, don't go to the next question. What is our human being tendency generally? Reading the question, first option correct, ticking and going to the next question. From this year onwards, that business will not be working out. What is it? First option, second, third, fourth, all options must be studied properly, must be analyzed. Then you have to take 1, 2, 3, 4, etc. I'm going to give the questions also on MSQ model when the time comes. Don't worry. Clear? Right. Now, major doubt, right? Whether you are getting or not. I'm giving the corresponding thing. What is it here is IFSD, full scale deflection, full scale value, full scale value IFSV or full scale deflection, both will be same. FSD means full scale, D means deflection, V means value. Both are maximum value indication. But people are asking, sir, why are you taking I only? General doubt, general doubt. Even you're getting or not, I need to clarify right now. Sir, can we take, if it is a voltmeter, can we take S is equal to 1 by VFSD? No, no. If it is a wattmeter, can you take S is equal to 1 by PFSD? No. Either ammeter or voltmeter or wattmeter, we should take the sensitivity always as IFSD only. Why? I will tell you when I start the instruments. When I start the instrument, once we start the PMMC, MI, EMMC, the same topic will be taken later again and complete expression will be given. Why I'm giving this means people will ask this doubt unnecessary. That's why always IFSD only. That's why I did not mention for ammeter, voltmeter. No, ammeter or voltmeter or wattmeter, always IFSD only. Why means very, very important note is there. I will give that note. I will explain the concept when PMMC, MI and EMMC instruments are being taken. That's why universally this is about sensitivity. Clear? Clear, guys? Right. Now, sir, based on this topic, to get the content, see, always I will do, immediately I will take the questions. Immediately I will take the corresponding topic to topic. Questions will be taken. So kindly concentrate. Right. Sensitivity related questions I'm taking now. Right. Read the question and try to answer. Come on. Right. Few people A, few people B, few people C, okay, other people D. Everything All options you have covered. Be clear. Very simple question. To 100 microampere full scale PMMC meter. Okay, some meter. Don't worry about this one. Some meter. Right? IFSD1 100 microampere. IFSD2 because second meter also 100 microampere. Okay. This is used to construct 10 volt. This is used to construct 100 volt voltmeter. It doesn't matter. Already told you. It is with respect to only current. So that's why direct answer in both the cases. Sensitivity of 1 and 2 is equal to 1 by IFSD 1 and 2. So therefore 1 by 100 microampere. So 1 by 100 0.01, 1 by micro mega, 1 by ampere ohm per volt, 0.001 mega ohm per volt. Clear? What is the answer? At least no. First option. 0.01 mega means 100 kilo. So option A. Direct answer. Clear? Right. Let me take one more question. Come on. Right. Very good. Very good. Right. Few people gave the correct answer. Right. Concentrate here. One small confusion will be there. Generally, few people are giving 300 also answer. Be clear, guys. 200 volt voltmeters means here 200 volt voltmeters. This is V1. This is V2. 100 volt, 100 volt. It is having the sensitivity of. It is having the sensitivity of first meter I'm writing S1 10 kilo ohm per volt, S2 20 kilo ohm per volt, 10 kilo ohm per volt, 20 kilo ohm per volt. Right now, what is asking? Find the maximum voltage that we can measure with this combination. Concentrate with this combination. So therefore, what is the logic here? Yes, what is the V maximum measurable with this entire thing? That's what he is asking. Okay, now first step, concentrate, sir. With this sensitivity, first I'm finding its full scale deflection current, IFSD1. What is the formula? 1 by S1, because sensitivity is 1 by FSD, means IFSD is 1 by S. 1 by 10, 0.1. 1 by kilo means milliampere. Okay, right here. IFSD2, 1 by S2, 1 by 20, 0.05 milliampere. Right. After getting this, majorly people are getting confused here. Yes, people are giving C also. Right, correct. Concentrate, sir. Its full scale deflection current is mean 0.1 milli. Its full scale value is 0.1 milli. Its full scale value is 0.05 milli. Okay, sir, what we require? V maximum requires. V maximum measurable. So that's what I'm writing here. Therefore, V maximum measurable is equal to, what is general formula of V? Current maximum, right, allowed into total resistance, into total resistance. This was the simple point, right? Okay, sir. My question here is, sir, what is the maximum current allowed through this one? What is the maximum current allowed through the combination? Why? He is asking combination based answer. Therefore, through these 2 meters, which is the maximum allowable current? Here people are getting confused. This is a genuine doubt. No problem, sir. 0.1, 0.05, which is more? 0.1 is more. Okay, I maximum is 0.1. Okay, let me take this. Sir. Let me take this. Concentrate. 0.1 milliampere. Okay, right. Sir, what is the R total? Now, sir, here, what is its R total here? Full scale value of voltage is there. Full scale value of current is there. So, automatically, resistance R1, V by 100 by 0.1 milli. So, 1000 by milli. What is it? 1 mega ohm. And its resistance is R2. What is it? 100 by 0.05 milli. So therefore, what is it? 2 mega ohm. Okay, let me come. Sir, 1 mega ohm is this resistance. 1 mega ohm is this resistance. So therefore, 1 mega plus, 2 mega. 1 plus 2 mega. What is it? Both are coming in series. He has only given series connection. So therefore, R total is 1 mega plus 2 mega. Sir, 0.1 milli into 3 mega. You will be getting 300 volt, but this answer will be there in the option. Few people gave the answer. Few people gave the C option. But is it correct? No, because concentrate. In this, we are not having the maximum current of 0.1 milli. See, he is not asking which is the maximum among the available. No, what we require here? Maximum current allowed. Maximum current allowed by these 2 devices. So which one here? Simply check it. Analysis I'm taking. Sir, I'm sending 0.01 milliampere, for example. Suppose if I send, both meters will be safe or damaged. Safe, why? So 0.01 milli. It can carry up to 0.1 milli. So 0.01 means it can be safe. So its full scale value is 0.05 milli. Therefore, 0.01 means device is safe. Okay. If I send 0.05 milli, sir, 0.05 milli is flowing to this. It can carry up to 0.1 milli. So 0.05 is less only. So meter 1 is safe. Sir, meter 2 also can carry up to 0.05 milli because its full scale value is 0.05 milli. Correct. Suppose if I send 0.06 milli. If I send 0.06 milli, meter 1 will be safe, but meter 2 will be damaged. But what he is asking, with the combination means both meters should be having the safe operation. That's why the maximum allowed current is how much? That's what I'm writing here. Therefore, I maximum is how much here? 0.05 milliamperes only, not 0.1 milli. Because he is not asking which is maximum among these two. No, which is the maximum current allowed by the combination. This is not at all measurement technical term. This network theory technical term. Both elements are in series. This is X capacity, Y capacity. Among these two, current has to flow means which is the maximum current. Means this will be the maximum current. That's why you need to write 0.5 milliampere. So finally, you'll be getting 150 volt is the answer. 100% chance is there to choose the wrong answer. That's why I have taken the wrong procedure first. What will be the general mistake? After that, complete answer. Clear, guys? Right. Not understood, sir. While I'm explaining, if you're typing, you will not understand. Definitely not only now. Until I complete the subject, until all the subjects are being taken, you will not understand while I'm explaining. When should you answer? After my question, is it clear means then you should answer understood or not understood. But before you type means you will not understand any time. I'm openly saying. Right? See, what is the instrument capacity? What is the instrument capacity? 0.1 milli. It can allow up to how much? 0.1 milli it can allow. Okay. It is not flowing. It is the full scale deflection current. Full scale deflection current. It will allow up to which one? 0.05 milli. Means its full scale value is 0.05 milli. Okay. Right. For having the clarity, I'm giving clearly 0 to 0.1 milli is there, connected in series. 0 to 0.05 milli is also there. Now tell me how much current I can give through this. How much maximum current I can give through this. I'm explaining that only. How much maximum current will be flowing through this. Sir, it will allow up to 0.1 milli, but it will allow up to 0.05 milli only. Yes or no? Means full scale deflection. Now tell me what can be the maximum current to be given to the combination. Suppose if I give 0.1 milliampere, for example, 0.1 milli is flowing like this. It can carry up to 0.1. It is safe, but it will carry up to its capacity is 0.05 millimeters. Instrument damaged. Okay. Second thing, sir, I'm giving 0.09 milli. Sir, 0.09 milli is coming here. It will allow up to 0.9 safe. So 0.1 safe, but 0.05 means damaged. Okay. Next, sir, I'm taking now here 0.06 milliampere. It will allow up to 0.1 milli safe. Here, it will allow up to 0.05 milli only, but you're sending more than this, means 0.06 milli damaged. Okay. Now I'm taking, sir, 0.05 milli. 0.05 milli. Yes. What is that? Yes, it is safe. 0.05 milli, it is also safe. Now tell me, more than 0.05, can we allow through this one? Yeah, no way. That's why maximum allowable current is this one. I am not asking which is maximum. Those no, which is the maximum allowable current, that is 0.05 milli. That's what the thing. I will repeat definitely. I will repeat every time. Right. Clear? Our topic is series. First, let us understand series. Later, we'll go to the parallel combination later. Okay. Those who told me to repeat, I have repeated with clear-cut, basic, simplest example. Clear? I know this is a general doubt. That's why I told you before my explanation. I told you many people will get the doubt. Listen carefully. I told you. That's why I gave the simplest example. I hope it is clear now, at least. Right. Yes. Vashishta, right. Okay. Now, let me take one more question here. Try this. Try this. Yeah, Nayan Sanjay Kalaskar, correct. Correct. That I'm going to show in this. That I'm going to show in this. Don't worry. Correct. It is a 2 minute, 2 mark question. Yes, you can take 2 minutes time or 3 minutes time. Kindly give me the answer. Right. Okay. I'm doing now. How many meters are there? 3 meters. V1, V2, V3. 3 meters are connected in series with the 120 volt supply. 120 DC supply. Okay. Right. Each and every meter details are given. Each and every meter details are given. So what is the data? First one, 100 volt, 5 milliampere means full scale value 100, full scale current required is 5 milli. Here, second one, 100 volt, 250 ohm per volt. Ohm per volt means sensitivity. And 100 milliampere and 5 kilo ohm resistance. This is the given data. Okay. Now, sir, estimate the readings of each voltmeter. Readings of voltmeter means across this voltmeter, how much is the voltage drop? Across this voltmeter, how much is the voltage drop? That you have to calculate. Okay, right, sir. Very, very, very simplest step I'm giving, simplest one. Sir, find out its resistance, R1, right? Full voltage, full current. So simply 100 volt by 5 milliampere. 100 by 5, 20. 1 by milli kilo. So 20 kilo ohm resistance is there for meter 1. Now, so in this R3, directly given 5 kilo ohm. Happy. Half of the data he has only given in third case. But in the second case, how do you get the resistance? Very simple, yeah. Concentrate. Sir, 250 ohm per volt means 1 volt consists of 250 ohm. 100 volts, how much? So directly what we can write here? 250 ohm per volt into 100 volt. Volt will be cancelled. Ohms, that is what we require. So simply 250 into 100, 25 kilo ohm. 25 kilo ohm. Right. Yeah, few people give the correct answer. Sharat Kumar, kindly check it. Dinesh, also kindly check it. Other people correct. Jadhav, Divya Shri is correct. Pragati correct. Shivagopi correct. Right. Other people kindly check it. Right. See, 20, 25, 5. So 3 are the resistances. So indirectly, now what we can write now? Simply network theory model. This is 120 volt. This is 20 kilo ohm, 25 kilo ohm, 5 kilo ohm. Across this, what is V1? Across this, what is V2? Across this, what is V3? Kindly simple voltage division law. Network theory is not completed in the AS Academy. Don't say that kindly. Right? BTech second, third year, fourth year students know. As voltage division law, you should know. Kindly simplify and tell me. Right. What is the answer? Voltage division law. What is the formula? V1 is equal to total voltage into where you are finding V1 means across 20K, 20K by sum of all these 50K. You'll be getting 48 volt. This is one answer. V2 is equal to 120 into where you're finding 25 by 50. You'll be getting 60 volt. Second one. V3 120 into 5K by 50K. What is it? 12 volt. Even after getting that, just verify. 45 plus 60, 108 plus 12, 120. Yes, satisfied. 120 equal to 120, satisfied. Nice. Vishnu Ajit. If we take the current method as previous, we are getting different answer. Which method? Current method means which method you are taking? You can do in the previous model also. You can do in the previous model also. No problem. But what what mistake you do in that way, sir? After calculating the resistor, kindly concentrate here. After calculating the resistor, what mistake you are doing? You know, you are multiplying 5 milli into 20 kilo ohm. So therefore, 100 volt you are saying. You are saying that 100 volt because here 5 milli is the current and correspondingly 20 kilo ohms is there. So current into resistance voltage 100 volt. Are you clear or not? See, if this is the 5 milliampere current is flowing through the meter or maximum capacity. All I told you 5 milli means not flowing current here. It is full scale value. Full scale value voltage, full scale value current means suppose one device is there like this 0 to 5 milli is there. Do you say always 5 milli is flowing? No, 1 milli, 2 milli, 2.5, 3.5, 4.5, anything. So that's why even if you are doing the current method, you will get the correct answer only. But what mistake you do? Yes, you will be multiplying 5 milli into 20K. No, 5 milli is the full scale capacity. 5 milli is not the flowing current. But what we require? Reading of voltmeter means voltage drop across this. Voltage drop across this. That's why be clear with the terminology. Clear? R2. So kindly tell me R2. So kindly tell me R2. I got 250 ohm. All I told you here. Already I told you. 250 ohm per volt. 250 ohm per volt. 1 volt. 250 ohms. 100 volts. How much? Into multiple. 250 into 100. I gave you already. Kindly look at the screen. Look at the screen. It is already there. 25 kilo ohms. And Muthireddy Vashishta. Sir, applying V1 plus V2 plus V3, found the currents as 4 milli, then applied V equal to IR is wrong. Means you might have wrong, you might have done wrong thing in the corresponding current. You might have done wrong thing. Right? Kindly check that. That's what I told you. If you are taking the current method, some mistake might be there. So that's why kindly verify that. Definitely at any cost, after getting that 48 plus 60 plus 12 equal to 120, then only your values are correct. Right. Urukunda Satish, sorry sir, getting, yes. Right. Whoever is getting 4 amperes only, what is it 4 amperes? Sai Charan Reddy, what is it 4 ampere? No sir, we are getting 4 amperes means kindly I told you to verify. That's why the habit is doing the mistake, throwing on the faculty. First you verify. I gave the correct answer. So why are you getting wrong answer? Verify it. Very good. Jaya Lakshmi, even with current method also we are getting, sir. Very good. Happy ma. Very good. Yes, Bhagat, correct. Namrata Deepti, got it, sir. That's why spend time, Rayar. Spend time. I gave one method after the class. Do in the other method. Try wrong answer. Again try wrong answer. Again try. Then you get it immediately. Now only. So that is not coming. That's why I told you. Whatever I'm explaining, listen. Those who said that other method is not coming wrong answer, you did not attend my procedure. No one will help you in this world then. If you are missing the topic like this. Okay, see, intentionally I'm saying like this so that at least you need to change your mindset, because this is a starting stage of gate preparation. If you continue that type of mindset, you will face the problems in the complete preparation in coming months. That's why intentionally I'm saying that if you do like that, no one will help you. I'm intentionally I'm saying to pinch you so that you need to change. I told one procedure, you listen this procedure. After going home, you take other procedure and solve it. Right? Right. Now you got it. Right. Sir, I also did the same 4 milliampere mistake before. They actually kept the maximum cut. Okay. Even after doing the mistake, if you get corrected from your side, I'm happy. Because I don't know which procedure you are using, right? That's why first follow my procedure. After that, I followed the voltage procedure. You follow the current procedure. I followed KVL. You follow KCL. Answer should be same. If answer is not same, understand that some mistake is there from your side. Correct it. Okay. Right. Next. But it's not possible to explain all the methods for one question, everything. No. So kindly concentrate. Right. Come on. Come on, direct answer. Yes, very good. Sir, here, what is that? A Wheatstone bridge requires a change of 7 ohm in the unknown arm of the bridge to produce a change in deflection of 3 mm. So therefore, delta input is delta R 7 ohm. Delta output production, what is that? Delta deflection is 3 mm. He is asking determine sensitivity deflection factor. Sensitivity equal to, what is that? Delta output by delta input. People are giving 3 by 7 only. Kindly try to give me the decimal value also. You'll be getting 0.425 mm per ohm. Right? Next. Deflection factor is 7 ohm by 3 mm. 7 ohm by 3 mm. 7 by 3, you'll be getting 2.33 ohm by mm. Clear? These two are the answers. Right, got it. Okay, this is the total discussion regarding sensitivity topic. Right? And some other questions will be solved later. No, but topic to topic, few questions I'm solving. Right? Next. Right. Sensitivity related question only. A voltmeter connected across the 10 kilo ohm resistor as shown in figure reads 5 volt. The voltmeter is rated 1000 ohm per volt and has full scale reading of 10 volt. The supply voltage Vs in volt. Try this. Try this kindly. Anyone? Option D. Few people gave that 8. Okay, 8 is not there in that. Okay, 80, 30. Okay, different options. Okay, very good. Everyone stop writing. Sir, what is voltmeter capacity? Full scale reading is 10 volt. Yes, definitely small mistake is possible. Concentrate. 10 volt. Right? Here. 10 volt is the full scale value. What is its sensitivity? 1000 ohm per volt. Okay. This meter is reading 5 volt. This meter is reading 5 volt. This is what the given data. According to this, sir, I want to calculate resistance of the voltmeter. Here, chance is there to do the mistake. Here, definitely chance is there Those are giving the different answer. They have done mistake here only. So resistance of the voltmeter, which is correct? I am writing two things, which is correct? You tell me. Here, 1000 ohm per volt into 5 volt, 1000 ohm per volt into 10 volt. Which is correct? First or second? First or second? Sai Praneeth, you have given first one. Right. Be clear. First, you have to understand here is this is the voltage drop. What he has given here? Voltage, the voltmeter reads. Voltmeter means we cross the voltmeter. This is the drop available over there. So therefore, concentrate. This is not its full scale value. Always sensitivity is with respect to full scale value. Why? Sensitivity means 1 by IFSD means with respect to full scale value. 10 volt full scale value must be combined. You should not take like this because 5 volts is not the voltmeter value. 5 volts is depending on the entire circuit because from this some current is coming. Based on this current, voltage will be dropped across this is that is 5 volts. So that is the reason why you need to concentrate with respect to full scale value only, but not red value. So that's why what's the value now? 10 kilo ohm. Very, very, very important point. Clear? Right? Okay. Now, therefore, and now I'm modifying the diagram. This is the simple diagram. What is this? This is Vs. He is asking Vs only. This is 50 kilo ohm. This is 10 kilo ohm. This is 10 kilo ohm. Across this, 5 volts is the drop. Okay. 5 kilo, 5 kilo. It's a 10 kilo, 10 kilo combination, 5 kilo. So therefore, what we can draw now? 5 kilo ohm. Here it is 50 kilo ohm. Vs is unknown and across this 5 volts is the drop. Apply the voltage division simply. What is it? 5 is equal to 5 is equal to total voltage Vs into 5 kilo ohm by 5 kilo plus 50 kilo. 5 kilo plus 50 kilo. This will be 11. So Vs is equal to 11 into 5, 55 volts. Clear? That's why don't take like this. Don't take like this. Clear, guys? So always the sensitivity means 1 by IFSD. Sensitivity means 1 by IFSD. I'm doing still people are giving the D option, 30 option. Come on, come on. Vishruth, I told you. Which answer? 55. What's the answer here? This. Not 80. Right? You should not take like this. You should take 1000 ohm per volt into 10 volt. So therefore 10 kilo, 10 kilo, 10 kilo, 5 kilo, 5 kilo and 50 kilo series across this, which is the drop means voltmeter reading means voltage drop across the voltmeter, that is 5 volt. That is 5 volt. So therefore 5 volt equal to Vs into combination 5 kilo by this. So 55 volt. Clear? See, I applied the voltage division notation. You can take it as the current notation also, as people are saying that, sir, 5 volt by 5 kilo, 1 milli into this entire thing, as you wish, anything, no problem. I am following KVL, you are following KCL, no problem. Unless and until you are not violating the main KVL concept, no problem, anything you can take it. Clear? Right. Now the next topic is resolution. Resolution. Right? Now, sir, I'll give the definition first. Resolution means the smallest measurable input change The smallest measurable input change is called as resolution. Resolution is also a quality of the instrument. The smallest possible, the smallest measurable, or the smallest possible measured value, the smallest measurable input change is called as resolution. This is what the definition, but I'll explain. After my explanation, I'm expecting you to give the formula. I'm expecting you to give the formula after my explanation. Concentrate. Sir, I'm taking one instrument. Just idea purpose, I'm explaining. Sir, concentrate. Here, 0 to 1. 0 to 1 ampere is there, for example. Right? In this, just like this, so many divisions are there. Approximately, I'm taking as 100 divisions are there. How many divisions are there? 100 divisions are there. Clear? What is it? 0 to 1 ampere, 100 divisions are there like this. Okay. Sir, if it is having 0 to 1 ampere full scale, 100 divisions are there. What is each division value? What is each division value? I'm writing here. Sir, each division value. How do you get each division value? Simple mathematics. Total number of divisions are 100. Full scale value 1 means simply 1 by 100. What's the value? 0.01. Clear? Right, sir. Same type of instrument I'm taking, 0 to 1 ampere only, but I'm taking, assume that 1000 divisions, for example, 1000 divisions I'm taking. Clear? Now, sir, in this, what is the value of each division? What is the value of each division? 1 by 1000. So 1 by 1000, that is 0.001 ampere. Okay, right. Now with this entire explanation, now tell me the smallest measurable input change. The smallest measurable input change is called as resolution. Now tell me, according to this entire construction and all, what is the smallest measurable input change we can measure with this one? With this device, what is the smallest measurable input change? How much is the value? What is the smallest measurable input change? Come on. Yes, very good. 0.01 only. Why? One division only, the smallest measurable input change. Do we have less than one measurement? Means my question is, suppose one scale is like this. This is 0 division, this is 1 division. Right? Do you measure this value properly? Come on, guys. 1 division, second division, like that. 100 divisions are there, for example. Do you measure below 1 division? No, right? It may be 0.05, 0.06, 0.07. We don't know. We don't know. That's why below 1 division, we cannot measure. That's why the smallest measurable input change is always which one here? 1 division value. 1 division value is the smallest measurable input change. So therefore, what is that? The smallest measurable input change is called as resolution. In this instrument, let me take A instrument. What is the smallest measurable input change here? 0.01. So therefore, this is resolution. In the second instrument, the smallest measurable input change is 1 division. 1 division equal to this one. So therefore, this is the resolution. Okay. Now tell me the formula. What is the resolution formula? Sir, this is the definition based resolution value. How you are getting this value? 1 by 100. What is 1? Full scale value. What is 100? Number of divisions. So therefore, what we can write here? Full scale value. Already few people have given that full scale value by number of divisions. Actually, formula to be given first, but after the explanation of after having the total explanation, I am asking you the formula. Full scale value by number of divisions. Clear? Right? What is it? The smallest measurable input change is the definition of resolution. In this, which is the smallest measurable? 1 division will be the smallest measurable. Below 1 division, we cannot measure properly. That's why. What is that? Yes, 1 division value we have calculated 0.01. That itself is a resolution. In this 0.001, that itself is a resolution. Clear, guys? Only definition is done. So many things we'll be taking now. Right. I will give the question. With that question, I'll give the break. Just try here. Resolution will be improved. Resolution will be improved with the number of divisions dash. Options increased or decreased. Don't worry. First take the break, get relaxed, come back and try this. I'll explain this. Take the break and come back. I'll continue the topic. Resolution is not completed, just started. Yes, come on, guys. Right. Very good. All of you have given the correct answer. What is it? Increased with the number of divisions. Increased. Right, sir? How? Very simple. Concentrate here. Sir, in this 100 divisions are there. 100 division, the smallest value is 0.01. But here 1000 divisions 0.001. Which is the smallest among these two? 0.01 or 0.001, which is smallest here? This is the smallest. That's why from here to here means in the A instrument and in the B instrument, where we are measuring as small as possible value means in the B instrument. That's why, what is my question here? Resolution will be improved. Resolution will be improved means as small as possible value we need to measure. That's why resolution will be improved with the number of divisions always increased. Clear? One thing. Second thing, very important note here is, sir, resolution will be defined only for linear scale devices or also non-linear scale devices. Means the resolution is defined only for linear scale, not for non-linear. Sir, why? Check it. Sir, suppose like this is the 0, something is there like this. Suppose scale is like this, 0 to 10, right? 1, 2, 3, 4, 5, 6. So can we say 10 by 6 is equal to each division? Can we say like that? No, we cannot say like that. That's why for non-linear scales, the resolution cannot be defined. But problem is not with the resolution. Problem is with the non-linear scale. That's why the drawback of non-linear scale is nothing but resolution cannot be defined. And we cannot say like this also. What is that? Right. See, here 7 divisions are there. Each division is equal to, let me take 12 for example. 12 by 6 is equal to 2. Can we say this is 2, this is 2, this is 2, this is 2, like that? 2, 4, 6, 8, 10. Can we say like that? Yeah, no, gap is more displacement should be there. Here 8 to 10, 6 to 8. Is it possible? Yeah, no. That's why resolution cannot be defined for which one here? Non-linear scales of instrument. So therefore, very important notice, resolution is not defined. Resolution is not defined for non-linear scale instruments are non-linear scales. Clear? Right. And a few people are answering like, sir, this is decreased, sir. All I told you after the break, that is the first topic, that is increased, and also explain the topic also. Explain the topic. But here, don't get confused like this, sir. The question is, resolution is improved. People are doing this mistake. Sir, increased means decreased. I am not asking resolution is increased. I am not asking resolution is increased. I am asking resolution is improved. Resolution improved means resolution itself is smallest measurable. That's why this is large value compared to this. This is small value compared to this. Therefore, which is the smallest? B instrument is the having smallest measurable. That's why instrument B has better resolution, good resolution we can say. So that's why resolution is improved means small value we need to go for it. That's why the definition is like this. Okay, so based on the definition I gave, that resolution will be improved with number of divisions decreased. Clear? Right. See, sensitivity and resolution. People are asking, Rand, this is what the main problem. So resolution is 0.1, sensitivity is 0.05. How can you take it? Show me that first. How can you take it for a device? Show me that. Sensitivity is 0.05. People are saying that's why don't take a random values for a given device. Take some numbers and then analyze it. I can imagine anything. This is what happened. That not like that, not like that. This is the practical subject. This is a practical. That's why take the instrument scale and take the sensitivity value, take the resolution value. Then you ask the question. But randomly, this is 5, this is 100. So what? Don't ask the question like that. Kindly don't get the doubt also. Clear, Jadhav? What are the question you type? Kindly show me the instrument for this. For that, show me the instrument. Right? Right. Next, I'm coming now. Generally, if any instrument is having high sensitivity, we say that instrument is having good resolution. Or if any instrument is having good resolution, then we can say that instrument is high sensitive instrument. I'm repeatedly saying, still people are typing the same way. Before my explanation, they're asking the doubts. Keep on. Okay. Leave it. What is it? If resolution is good, sensitivity is high. If sensitivity is high, resolution will be good. Both will be working together. Both will be working together. So therefore, high sensitive instrument generally treated as best resolution. Best resolution instrument generally treated as, yes, as high as possible sensitivity is there, we can say, because both are related to smaller values measurements only. So therefore, both are together, we can say. Clear? So this is the total discussion related to the corresponding resolution topic. Clear? Right. Now, I'm taking one example. So that you can understand the topic clearly. No one should write anything. I will explain this. Sir, a moving coil voltmeter has a uniform scale. I told you, non-uniform resolution cannot be defined. Therefore, uniform they have given. Even though they have not given this word uniform, you should treat as a uniform only, definitely, because resolution is defined only for uniform scales. Okay, right, sir. 100 divisions are there. Full scale reading is 200. Kindly forget about this entire statement. I will come to this later. Forget about this entire statement. We'll come to that later. Sir, what is the full scale value? 200. What is the number of divisions? 100. 200 by 100. 2. First option is there. To confuse you, the question is given like this. First option is given as 2. Clear? First option is given as 2. Right? Okay. So the point here is, what is the question? Concentrate. Right, sir. 0 to which value? 200 volt. 0 to 200 volt. How many divisions are there? 1, 2, 3. Like this. Divisions are how many? 200 volt. Okay. 100 divisions are there. Okay. Very good. 100 divisions are there. Okay. Right, sir. 200 volt by 100 means this value is 2 volt, 4 volt, 6 volt, like this. We are going to like now. Sir, what is the resolution? Resolution is equal to 200 volt by number of divisions are 100. Number of divisions 100. People are saying that 2 volt. But question is not completed yet. What he has given? Concentrate. 1/10 of a scale division. 1/10 of a scale division can be estimated with a fair degree of accuracy. What does it mean? According to the given question, right? Which is the smallest measurable input change? According to the given question, which is the smallest measurable input change means 1/10 of a division can be estimated with a fair degree of accuracy. Means 1/10 of the division is able to be measured over there. That's why in one division they are measuring up to 1/10 part of the division like this. So therefore How many divisions are there here? 10 subdivisions are there. Okay, now according to the given question, one division is not the smallest. In this question, according to the given data, one division is not the smallest. If nothing is given, I told you one division. All I told you in this example, I told you one division. But in this question, clearly mentioned that in one division, 1/10 part in one division, 10th part is able to be measured. 10th part is able to be measured means here 1/10 of the division means, so totally this is the smallest measurable input change. Okay, now tell me how many total number of divisions are there now? 100 normal. In each division, 1/10 of the division is able to measure means here 10, here also 10, here also 10, like that. Totally how many divisions will be there here? 100 into 10, so totally 1000 divisions will be there. Therefore into 10 we have to take, so therefore answer is 0.2 volt. Be clear. If this is not given, okay, if this is not given, happy. What is the answer here? 2 volt, correct. But if 2 volts is it, that is not the gate model question. That's why small twist. 1/10 of the scale division can be estimated with a fair degree of accuracy. Means in one division, 10th part they are able to measure means smallest measurable value is what is it? But 10th part of the division. Yes, 10th part of the division is that one. So answer is 0.2. Clear? Yes, already many people give the answer. Yes. Got it, guys? But, sir, unit, what is the unit? Be clear. Suppose if this data is not given, if this data is not given, what is answer? 200 volt by 100 divisions. Therefore, 2 volt per division we can say. But what is the data? 1/10 part of the division. 1/10 part of the division means actually 1000 divisions are not there. 100 only there. But in one division, 10th part they are measuring. That's why we cannot say 1000 divisions are there. Strictly speaking, simply 1000 subparts are there, but strictly 1000 division they have not given. We are making 10 in one division, 10 in one. That's why we should not make volt per division terminology. Simply in the denominator, they don't give. Simply they will give volts as the corresponding unit. No need to worry. Suppose if this is not given like this, yes, 200 volt perfectly, 100 divisions perfectly, then volt per division we can say. But in this, part of the division is there, no. That's why denominator, they will not give anything. Yes, acceptable terminology only, no problem. This is the total discussion regarding resolution. Clear? Right? No. These two notes are very, very, very important. These two notes are very, very, very important. Right. Right. See, people are asking this question also. Come on, yeah, come on. Sir, after taking the 200 by 100, 2, after that, can I take 10? What is this question? Right? Okay. Now, next characteristic is dead time and dead zone. Very small topic. Dead time and dead zone. So always be clear. Dead time and dead zone is defined. Dead time and dead zone is defined only at starting of operation. This is defined at starting of operation only. It is defined only at starting of operation. Very, very simple, sir. Suppose one instrument is there here, right? Here, one instrument is there like this. Sir, the moment we give the supply, does the pointer get moved instantly? Does the pointer get moved instantly if the supply is given? No. What is it here? The pointer has small mechanical inertia. Therefore, the pointer has to overcome that definitely. And people are saying that, sir, you told that some bearings are placed, etc. Yes, even though bearings are there, friction can be reduced, but friction cannot be eliminated. So that's why the moment we give the supply, pointer will not move in a zero time. Pointer will be taking at least nanosecond or picosecond of time delay. That is called as dead zone or dead time. So that's why always this is defined at the time of starting of operation. What is it? Due to inertia of the pointer. Due to inertia of the pointer, we say. What is it I'm showing now? Sir, this is input. Some input supply is given. This is response of the pointer. Nothing but output response of the pointer. What is it? Supply is given. This is output response of the point. So supply is ideal condition. Friction is zero. Is it possible to have friction exactly zero practically? No. Friction will not be zero exactly. Friction can be minimized. So that's why start here, right? Input is given, input is given, input is given. No, it is not at all giving the response. Assume that at this point, it is giving the response. It may be straight line, any one line. That depends on the nature of the system. So therefore, now tell me, this much of time is wasted in the corresponding operation. That's why this time is called as dead time. Means in the x-axis you can take time as well as input also. This much of input is wasted. This much of input is wasted. That is, for this much of input there is no output. For this much of input there is no output at all. So therefore this is called as either dead zone or we can call dead time. Suppose if the x-axis is taken as time, time taken by the pointer to respond, dead time. Input, the minimum input required to have the response in the system, that is called as dead zone. Both are interrelated. Dead time and dead zone. I'm giving the definition. Time taken by the dead zone is dead time. Input wasted in the dead time is dead zone, vice versa is there. Now tell me, dead zone and dead time will be there or will not be there for a designed system. Means dead time and dead zone will be there definitely. Dead time and dead zone will be there definitely. But we need to talk about as small as possible dead time or dead zone, or as large as possible. Means as small as possible dead time only we need to concentrate. So that's why be clear, the friction must be as minimum as possible. There automatically dead time and dead zone will be automatically as small as possible. Okay, right. So my question here is concentrate, sir. This is also called as one more terminology. I'm giving 1 minute of time. Kindly tell me this dead time or dead zone in other terminology, in the other way, what we can say this. Name only I'm asking directly. Dead time and dead zone is also called as. Come on. Come on. You know this. You know this. You know this. Kindly respond. Delay, inertia. Okay. Not like. Okay. Simply that is called as threshold. Okay. Okay. This is also called as threshold, but actually threshold is a word generally we use in the analog electronic diode case, etc. But same thing, threshold voltage means the minimum voltage required to have the response, that is threshold voltage. Here threshold nothing but the minimum value, at this no response, at this no response, so therefore only at this response is there, so therefore that is called as threshold. So therefore I'm writing here the smallest detectable, the smallest detectable input, the smallest detectable. See, this is 0, this is 1, for example, 1 ampere, for example. 0.1, is it detected? No. 0.5, is it detected? No. 0.8, is it detected? No. But 1, yes, it is detected. That's why the minimum detectable input, the smallest detectable input is called as threshold. That is in our electrical language called as simply dead time or dead zone. Dead time or dead zone. Urukonda Satish, do you get saturation at input? Come on here, what are you talking? Input, you are saying that saturation. Input operation itself is not started. Is it saturation here? No. Saturation will be after the operation. It will be getting the saturation. Be clear. So this is the total discussion regarding all 10 characteristics, all 8 characteristics. What are those? Accuracy, precision, drift, hysteresis, linearity, sensitivity, resolution, dead time and dead zone. Dead time and dead zone. Okay, all the topics along with the corresponding numerical questions and corresponding conceptual questions, everything I have taken. Clear? Right. Now, the next characteristic is significant figure. It is a special topic. Definitely, it will be the completely new topic to you. Generally, in the normal BTech level, etc., we don't concentrate on this topic generally. So that's why I'm saying this. See, people are asking, sir, dead time and dead zone both are same or different? Just now I told you, time taken by the dead zone is dead time. Input is wasted in dead time is dead zone. Magnitude will be same, but unit will be different. Both are one and only same, but we should not say that because unit will be same. Time, seconds. Input may be current, voltage, power, energy, temperature, anything. So that's why I have written no, dead zone or dead time. This is the area, dead zone. This is the time, dead time. That's it. Okay. Right. When I have to take dead time, when I have to take questions, when I have to take the concepts, I know whatever the thing I'm explaining, kindly take it. Okay. Significant figure. Few topics will be conceptual, will be there. Few topics will be numerical, will be there. So kindly concentrate on the topic. Okay. Significant figure. Sir, what is significant figure? First of all, what is its importance? What is its importance? Be clear. Sir, a value with more significant figures. A value with more significant figures is called as highly precise value. Is called as highly precise value. This is what the point. What is it? A value with more significant figures. A value with more significant figure, then that value is called as highly precise value. Means precision can be explained in two ways. Yesterday I told you, mostly repeated or mostly reproduced value is called as, what is it? Highly precise value I told you. That is experimental based. One more concept is, if the number is given with more significant figures, that is called as highly precise value. This is second way. In order to understand that whether the number is highly precise or not, you need to understand significant figure. So what is significant figure I'm giving now? This is the complete procedure I'm giving. Concentrate. Suppose I'm giving with example only, concept itself with example only. Suppose if any number is given like this. So in this decimal value, decimal point is there or not? No, decimal point is not there. Directly given as just 200. Directly given as just 200. Clear? Okay, sir. And one more number I'm taking. Here I'll take. Suppose 200.0. In this decimal point is, you can take 0.2, 0.3, any number, some number I'm taking. Next. 1995. A number without decimal means in the mathematical representation, only two things will be there: number with a decimal or number without decimal. So everything I'm taking now. Right. Next. here. Second one, 1995.6 something decimal point. Next, 0 219, some number, different numbers I'm taking, right? 0 to 11.7, like this, some number, different numbers I'm taking. Okay, right, sir. In this figure, how many significant figures are there? In this value, how many significant figures are there? Don't write anything. Kindly consider it is completely new topic to you. I'm clearly saying completely new. What is the definition of significant figure? If I do something, sir, why that, sir, means that is a definition. Be clear. When a number, when a value without a decimal point, when a number without a decimal point, when a number with a decimal point, two concepts I'm giving. When a number without a decimal point is given to you, you need to start counting from right side. You need to start counting from right side. How? Right side end 0. Count its, neglect its count. And one more 0, neglect its count. Non-zero came into picture. Then start counting up to the last digit. Only one is there. So that's why significant figures are 1. Significant figures are 1. But kindly consider, so many doubts will be there. Sir, how can you say 200 equal to 1? I'm not saying 200 equal to 1. This is 200 only. 200 rupees only. 200 volts only. 200 amperes only. 200 kgs only. Everything is 200. But in this number, how many significant figures are there? Means if any number is without a decimal point, then start counting from the right side by ignoring the count of right end zeros, and start the number count from non-zero until the last digit is there. Only one is there. Yes, one. Let me complete all the example, you will get the clarity. Sir, decimal point is not there. Okay, start counting from right side. Non-zero, 1. Start counting. Once the non-zero is there, count start. 1, 2, 3, 4. How many are? 4. Okay, next. Sir, from right side, because decimal point is not there, right side, non-zero is there, starting. So 1, 2, 3. Don't neglect the left end zero count. Which end is zeros count you have to neglect? Right end zeros, but not left. That's why once you are getting the non-zero number, from that number to last number you need to count. Yes, 1, 2, 3, 4. But I'm not saying that these two are same. No, in this number, 4 significant figures are there. In this number also, 4 significant figures are there. This is the basic theory. So many rules are there, but what you require at the gate point of view, ESC point, that only I'm giving. That's why it is big ocean, but what are the things you require in this topic I'm giving. Now, next one. Sir, if left and, sorry, decimal point is there, then start count from left side. Sir, start the count from left side. If you're starting the count from left side, right, starting only non-zero, so therefore 1, 2, 3, 4. How many are? 4. Decimal point is there, count from the left side, starting only non-zero. Yes, 1, 2, 3, 4, 5. 5 significant figures. And start from the left side, already told you. Yes, 0 is there. Ignore the count. I'm not saying that remove the 0. No, ignore the count of 0. And 1, 2, 3, 4. This is the corresponding topic related to which one? Significant figure. But I'm requesting everyone, sir, sending one number, how many? Sending one number, how many? Don't give that question kindly. Follow these two. You can take any number, you will get the answer. But what is the rule? Decimal point is not there, come from the right side. Decimal point is there, come from the left side. But here, sir, 4 is there means you are, what is mean? Before or after definition and everything, its value is 200 volt, 200 amperes, 200 kg. Value is not changed. What is changing here? Significant figure we are defining. This is 200 only. It is also 200 only, but significant figures are different. In the way of significant figure, the difference is there between these two. But weightage point of view, 200 kg, 200 kg. 200 ampere, 200 ampere means weight point of view, there is no change in the corresponding, what is it, weight at all. Weight point of view, there is no change. Only significant figure point of view changes it. This is the definition of significant figure. This is the definition of significant figure. Right. Abhijit already told you. So if number is in the center, what I told you, left or right only concentrate. Left or right only concentrate. In the number is in between, left to 1, left to 2. If you are asking those questions like that, I need to answer thousands of questions. That's why try to understand terminology. Right side zeros only to be neglected. Here, left side zeros only to be neglected means, can't you understand that middle zeros cannot be disturbed or not? Yes, that only I'm saying. That's why you give 2 examples. Other give 500 members are there. One example, 500 questions I need to explain here. That's why follow these 2 theories. Other than that, wherever the 0 is there, it should be counted. That too, topic is not completed. Still, you are asking the questions in between my discussion. Intention pointing out so that you need to change. Not only you people, everyone, almost 5 to 10 members are there continuously typing. You need to change your mindset. You need to change your way of asking the questions. Then you will get the subject. Otherwise, you will face the music future. So kindly concentrate. Now, I'll give the example here. All varieties of doubts will be clarified with my examples. So kindly concentrate. Kindly concentrate. Okay, right, sir. One example I'm giving. Concentrate here. This is the question. I'm giving the example. Sir, A, B, C. 3 things I'm taking. 102 ohm. 0 is at the center. Satisfied, Abhijit? That's why let me give the time. Let me give the time. Every example I'll give you. Every example. All I told you, for which topic, in what way students will ask doubts. In that way, I'll already frame the questions and I will give you. Don't worry. Don't worry. Right. Next. 102.0 ohm, 0.000102 mega ohm. Something is given. What he is asking, comment on the precision. Comment on the precision. Here you have to understand one point, sir. When you have to comment on the precision means, see, highly precise, low precise is there, right? Okay, now people are asking this question. Kindly concentrate. You cannot comment like this. You cannot comment like this. Suppose, sir, 1995 is there, 2000 is there, sir, which is highly precise. We should not comment, because in order to comment the precision, the weight must be same. Otherwise, we cannot say 1995, 2000. Both are different values. How can we say which is highly precise, low precise here? No way. When you have to say means 2000, 0.0, 2000, you can say. Why? Yes, this is 2000 weight. It is also 2000 weight only. Yes, you can give the precision. Sir, 1995, 1995.0. You can. But number should not be different. Means mathematical weightage should not be different to comment on the precision. Okay, now check it here, sir. I'm giving the solution. After the solution, you'll get the idea. Concentrate. Sir, A is there. What is that? 102 ohm. Okay, leave it. B is there. 102.0 ohm. C is there. 0.000102 mega ohm. Okay, right, sir. 0.000102 mega can be written as 102 ohms or not? Mathematically, 0.000102 mega ohm, yes, can be written as 102. Now check it, sir. This is 102. It is also 102. It is also 102 only. Yeah, therefore, yes, mathematical weightage is same. Then we can go for commenting the precision. Are you getting the point here, everyone? When we are supposed to comment on the precision means, if any 2 numbers you are comparing in terms of precision means, weightage must be same. Then only we can comment the precision. Otherwise, simply get the significant fake values and leave it. Don't say which is highly precise, which is low precise. Don't comment. If you want to comment the low or high precision, you should have same mathematical weightage like this. Clear? Right? Now, let me take this. Sir, 102. How many significant figures are there? Sir, 102. Decimal point is not there. So start counting from right side. Actually, left and right, no zeros. Happy, no problem at all. So simply significant figures are 3. And decimal point is there. Go back. Decimal point is there. Start counting from left side. So left side. Non-zero. 1, 2, 3, 4. 4. Sir, 102. Neither zero left nor right zero left. So simply 3. Okay, now which is highly precised? B is highly precised. I'm giving the answer now. Therefore, B is highly precised. B is highly precised. And A and C are equally precised. This was the point. Am I clear, guys, everyone? Yes, few people give the 3, 4, 3. Very good. B, yes, Surojit and Nitesh gave the correct answer. Clear? So this is what regarding significant figure means. What is the importance of significant figure means? We can comment on the precision when equal weight is there. Equal weight is not there, we cannot comment on the precision, but significant figure we can find out and leave it. Which is having more significant figures, yes, okay, or which is having dash significant, like that questions will be given, find it on, leave it. But don't say that, sir, this is 4, so this is more than, no, yeah, this is 1995, this is after 200. How can you compare these two? No, that's why individually find out all these things. But if you want to comment the precision, weight must be same. But don't get the question like, sir, in the examination, weight is different. If he is asking on the comment on the precision, he will not ask and he should not ask and he cannot ask. Don't worry. Don't worry. Because that is invalid procedure. Clear, guys? Shri Bhashyam Rohit. Did you understand my language? Did you understand my language? Don't give the any number. And sir, how many significant figures? After listening the class, after going home, take one white paper, take thousands of numbers and find out the significant figure. Take the significant figure. Okay. First follow the rule, right? If you are giving one number, other are giving one number, find start. What is it? Theory you follow first, then go. Right? People are asking, sir, why B is highly precised? You missed the topic, I think. A value with more significant figures is called as highly precised value. Starting only I gave you. Starting only I gave you. Clear? Right. Ankuriam Kashyap. Sir, could you explain logically why B is highly precise? How can we say without calculating significant figure? Our topic itself is with a significant figure. My topic itself with significant figure. How can you say without significant means? Without significant figure, we cannot say which is highly precise. If you are saying that so and so is highly precise, that procedure is called as significant figure only. Clear? Ankur, clear? Our topic itself is within the significant figure only, we can comment the precision. When 2, 3 numbers are given, we need to compare those 3 means definitely we require simply significant figure approach. Clear? Right? Significant figure is a tool to define which is highly precise and which is low precise and all. Nice. Bhavani, on what condition these are used practically? I am giving the question in your experiment. Find out these 3 numbers, among these numbers, which is highly precise. That is what the practical application. Clear? I'm giving that three numbers are there, which is better precised. In your experiment, you got these numbers, which is highly precised. Means if you want to compare like that, yes, which is better, you have to compare. That's what the practical idea. Bhavani, clear? You got the experiment, you have done the experiment with the machines. One you got this value, other you got this value, other you got this value, and you need to take which is highly precise. There you take it. That's it. Experimental result. Right. Sai Charan, so why should we write number in three different? That is a question. Right. Now let us go to next topic. Range and span. Range and span. So what is range and what is span? Right. Very good. Bhosle, Pratik, Pramod. Yes, condition is mathematical weight must be same. Definitely, definitely, definitely. Right? Mathematical weight must be same. Then only they will ask the question. No need to worry. Then only we need to give the answer. No need to worry. Clear? Abhishek Kumar Singh. Thank you. Thank you. Right. Now I'm taking the next topic. Kindly concentrate. Right. So range and span. So what is range and what is span? Very, very, very important. Based on this range and span also, questions will be there. Mostly GATE and ESC, all examinations for both the branches, electrical and ECE, questions are possible. Listen carefully. With example, I'm explaining because in order to explain the topic, I need to have one example. Here, first I'm taking one thing. 0 to 300 voltmeter is there. This is one thing. Right? No, in this instrument. Sir, what is a formula? Range of any device formula is maximum minus zero. Maximum minus zero. Why? Our device is, this is 0 to something. That device only I'm talking. Maximum minus zero. Okay. And span. What is a span? You know, maximum minus minimum. Maximum minus minimum. This is what the formula. What is the range formula? 0 to full scale instrument will be there. No, maximum minus 0 is the range. Maximum minus minimum is the span. But in this, sir, what is maximum in my question? 300 minus 0. So answer is 300 volt is the range. Nothing but 0 to 300 voltmeter has the range of 300 volt. Okay, right. Next, sir, maximum 300. Minimum is also 0 only in this 0. So therefore 300 volt. The moment I complete this, generally people are getting doubts like, sir, for every device. Vignesh Nathan, yes, I know. Thank you. Right. Okay, before continuing this, one question. Why not take in C precision 9? Mega is there. Mega, milli, micro, nano, and all should not be present in the, what is that number? It should be a normal number. Then only we can give it. Good question. Right? Mega, milli, micro, nano, pico, femto, something values may be given. No, that must be converted into normal number. That's why I have done here. This is mega is there. Suppose if mega is not there, yes, you can say other value. Okay, right. Now come to this. Sir, here people are asking one doubt here, general doubt. Sir, always minimum will be 0 only. Therefore, always range and span will be same. No. The second way of question is concentrate. A voltmeter is A voltmeter is calibrated from what is calibration? I'll tell you. Calibrated from 150 volt to 200 volt. What is it? 150 volt to 200 only calibration. What is calibration? I'm going to explain. Kindly wait. Okay. Now in this device, I'm asking what is range? What is span? Okay. Right. Formula is same. Sir, maximum minus zero. Maximum minus minimum. Okay. Right. Sir, maximum is 200. Maximum is 200 in this. But sir, see, while you are defining the range, always the minimum value must be zero only you take. So zero. Here, no doubt, 200 volt. But according to the given data, consider I'm explaining the calibration. This calibration is the word we are going to continue throughout our entire measurement subject. Concentrate, sir. Calibrate. What do you mean by calibration? What do you mean by calibration? Means concentrate, sir. Calibration means one form of or one method of designing the scale. You remember this, after I explain elaboratedly. Means they have designed the scale such that 150 to 200 only means like this. This is 150, this is 200. Suppose if the pointer is showing like this, suppose it is voltmeter for example. If the pointer is showing like this, it will be 150 volt. Okay, 150, 160, 70, 80, 190, like that. 200 will be there. That's what the scale designing. Sir, what is the minimum value in this scale? 150. But sir, 0 to 150 is not shown, but below 150, 0 to 150 scale will be there, but that is removed. That is called as one of the methods of calibration, we can say. That's why, what is that? Maximum is 200, 0 is 0 only, maximum 200. What is it? Minimum value in this question is 150. So what is the span of the device? 50 volt. This is the total discussion regarding range and span. This is a design regarding range and span. Clear? Right? Vinay Kumar Chari, galvanometer, when I have to take, I know, I will take that later. Don't worry. Clear, guys? So this is the total discussion regarding range and span topic. But here, people may be having still doubt like, sir, 150 to 200 means what? Means 0 to 150, they have cut short. They have cut. 0 to 150, they have cut. Means starting only 150. Sir, why? Means in his operation, in his circuit requirement, 0 to 150 value is not there. All the values will be 150 to 200 only. That's why he is designing according to his operation. Below 150, I don't have any value in my experiment. So why to take that? So that's why 150 to 200 they are take. That is what called as we can calibrate the device from 0 to 100, 0 to 200, 10 to 100, 10 to 200, 50 to 100, anything we want, we can take it. But generally, instruments will be like this. But numerical point of view, if the device is calibrated from so and so 150 to 200 volt like that. Okay. The best example I'll give you. The best example, practical example. Everyone knows this example. Everyone knows this example. Right. So the point here is, sir, thermometer is there. Suppose thermometer is there. I think everyone knows that temperature measuring device. Not nowadays digital one. Olden day, we need to keep it in our right mouth. So therefore, that type of device is there. For example, something right in that reading will be there. In that reading will be there. Okay, right. In this mercury will be there. According to your body temperature, the mercury will be moving. Sir, your body temperature 98 healthy. Okay, 98 degree Fahrenheit healthy, for example. Okay, but on this device 0 degree, 1 degree, 2 degree, like that, 1 or 110 degree, will it be there like that? No, below 95, no need to check. Doesn't know, like common man healthy body temperature is how much? 95, for example, minimum. That's why what they do, They will keep 95. They will keep 95 directly. Now you are, suppose you are getting fever, etc. Now you are using the thermometer based on your temperature is going. Suppose this is 100, for example. The mercury level is up to this much, that will be raised. That will be raised up to this much. So what is your temperature? Body temperature 100, but don't say 95 to 100 means my body temperature 5 only. If body temperature is 5, you can expect what happens. Yes or no? That's why below 95, no need to measure. That's why calibration may be from approximately 90. If I am giving, it may be 90 or something. So therefore, whatever the values we don't require, simply those values will be cut out. From 95 to 110, elaboratedly they will take. That's why 100.5, 100.5, like that, 100 or 100.5 or 101, like that. Each and every value will be clearly indicated on the scale. So that's why below 95, we don't want 95 to 110. Okay. What is the range of the device? 110 minus 95. What is it? Sorry. Range. 110 minus 0. What is that value? 110 degree Fahrenheit. Suppose if I want to talk about span, 110 minus 95, so 15 degree Fahrenheit over. Because body temperature, normal healthy body to high fever temperature may not be more than 15 degrees change. So that's why this is what calibration. One thing. One more doubt is people are asking, sir, if the thermometer is on the table, so it will show 95. What happens? Nothing will happen. It will show 95 means, okay, body temperature not measured. Normally, it is at its lower level because it cannot go 0 level because lowest level is 95 in the device also. Suppose this is 150, this is 200. It shows 150 means, sir, even if you are not giving the supply, it will show 150 means it has to show 150 only. That is what the scale, but it doesn't indicate 150 is given. No, normally nothing is given. It will show minimum value of 150. That's what the point. So calibration, the moment you give the supply 155, 156, etc., it will show 160, 170, 180, 190, like that it will show. This is what called as calibration. Clear? Instrumentation people, those who attended my instrumentation before my subject, I told calibration is what, and I'm elaborately I'm explaining in detail here. There we have seen temperature into voltage, voltage into something else. You have seen, no? Yes, this is what actual meaning of calibration. Clear, guys? Right. Now I'm asking everyone, topic is clear? Can you respond? So that I can go to the next topic. Aishwarya, Sharath, I think if the supply is not given, it will show minimum value. No problem. That's what the scale. Right. Okay. Right. Next. One more doubt people are getting here is whatever the range formula and span formula, etc. I have given, what is my device? 0 to full scale value terminology. 0 to something is cut down. That is, suppose x to full scale value only. After few topics, I'm going to take power factor meter. I'm going to take galvanometer. What will be there? What is the concept will be taken later. When the topic is to be taken, I will take. No need to worry. No need to worry. But as of now, our topic is 0. Good question. 0 to full scale value based only. That's what I'm taking. Right. So what about power factor meter? What about galvanometer? Those are in the next chapters. I will take them later. Don't worry. Right. Right. People are asking one more question. Sir, if the range is 150, how do we know that? Sir, if the supply is 150, if the supply is 150, pointer will stay there only. If the supply is 151, it will move here. 150 to move here. Even after giving the supply, it is not moving, means supply given is 150 because 150 is shown by the device. No need to worry. One more thing, 150 to 200 means generally 150 exactly we don't use, 200 exactly also. The means is difference between this, means in between those two we use practically. In between those two we use practice. That's what the actual terminology. But even though it is showing 150, how do you know? Means 150 is showing no here. That is what 150 given. You know that supply is given. Still it is showing 150 means input given is 150. Increase the input, pointer will move. Further increase the input, pointer will move further. That's what the point. Okay, right. Good question. Right. Next one. These are the static characteristics, right? Now I'm taking dynamic characteristics. Right. And one more thing I wanted to say, videos are available, recorded videos are there. You can watch them, right? Means if any smallest confusion, actually doubt should be clarified in the class itself. That's a topic I'm asking. Still it is there. After that, recorded video is there. Go through that. You will understand. No need to worry. That is the reason why facility purpose only we are giving the recorded videos also. Do you people know or not? In the content section, notes will be uploaded as well as video will be also available. You can watch the video whenever you are having the doubt. No problem at all. Clear? That facility is there. Kindly utilize that. Utilize that. Right. Is it clear, guys? See, 150 to 200, I'm explaining again. 200, 0 is there or not there, doesn't matter. Range is always maximum minus 0 only. Maximum minus 0 only. And span is always maximum minus minimum given data. Minimum given data. One thing. Still people are asking one thing. Sir, if it is minus 2 to plus 2, just now I told you, our topic is 0 to full scale value only. Do you want me to explain Hindi? I'll explain. Do you want me to tell in Telugu? I'll tell in Telugu. If you don't understand my English. 0 to full scale value only I explain. Minus 2 to plus 2, that is galvanometer. I'll tell you later. Power factor meter also, I'll tell you later. Just now I told you, don't get confused. Right. Bhukya Bharat. Okay, good question. Concentrate. This is the question people are asking. See, maximum and minimum values same. How is it possible? Sir, maximum value and minimum value same. Then range and span will be same. Maximum and minimum. How can you say maximum and minimum both are same? Come on, Bharat. Sir, maximum and minimum value same unnappudu range and span. How do you get maximum and minimum both are same? Just show me the scale ones. Maximum and minimum both are same. Not possible, right? Concentrate. Okay. One more thing. Sir, maximum itself is full scale value. Try to understand. 0 to 300. 300 is a maximum. That is a full scale value. Here, full scale value. That is what maximum. That is what maximum. So that's why maximum means full scale value. Range means what? Full scale value representation only. Come to this. Dynamic characteristics topic is very simple. Yeah, very simple. That is dynamic characteristic. There are three characteristics. Speed of response, Speed of response. Very simple. Sir, what do you mean by speed of response? Very simple. Yeah? How fast it is operating. How fast it is operating. How fast it is operating. That is called as speed of response. So therefore, here, the rapidity of an instrument, the rapidity of an instrument with which an instrument responds, with which an instrument responds. Nothing but as the time is passing on, what we expect here, speed of operation must be as high as possible. That's why how rapidly the instrument is responding, that is called as speed of response. Speed of response. Speed of response itself is with respect to the time changing or not. Yes, that's why this is coming under dynamic notation. One thing, sir, do we prefer as high as possible speed of response or as low as possible speed of response? As high as possible speed of response or as low as possible response? Sir, definitely we expect as high as possible speed of response only. Clear? So therefore the point here is always we expect, what is it here, speed must be as high as possible so that we can have the faster response, we can see. One thing. Now, second characteristic is here, definitely doubt will be the technicality, measuring lag. Measuring lag. Measuring lag. Sir, what do you mean by measuring lag? What do you mean by measuring lag? What do you mean by measuring lag? Come on. Okay, right. One more thing. Just throughout the 3 days, I'm taking topic. Only 2 minutes I wanted to speak. First of all, everyone obediently tell me, are you able to understand? Because this is the first time you are facing. No, that's what I'm asking. Are you able to understand or not? Let me know one thing. Can you respond? Is my explanation and everything is clear or not? Everyone. Right. Okay, right. Very good. Sir, why I'm asking, few 10, 20, 30 people are leaving the session. The moment 8 is there, people are leaving the session. But again, tomorrow, next day, they are asking all irrelevant questions. That's what the main problem I'm facing actually. Not only me, every faculty problem is that only. That's why I'm openly saying here, kindly 5 to 9 means you should stay up to 9. Yesterday, I waited up 9:30 also, almost doubts clarification up to 9:30. Of course, almost 2 to 300 people were on the line only. That's why 5 to 9 is the class. Definitely stay up to 9 o'clock. Stay up to 9 o'clock. If you are leaving the session before 9 o'clock, 8 o'clock, the moment 8 o'clock, I'm getting tensed, etc. I'm getting pressure. No, you need to habituate it to attend the entire session. Then only you will get the subject. Then only you will get the best rank. And keep on saying that, repeatedly saying, your seniors only, last year people only told that, yes, sir, I missed the classes by thinking that I plan to watch the recorded videos later. Actually, recorded videos are to be watched after attending the class for the purpose of small doubt clarifications. That's simply watch the video, forward it, etc., etc. At whatever the point you are having the doubt, that you need to watch it. That is what the actual purpose. But by thinking that I will watch the video after 1 day or 2 days, etc., you will not watch, because that is the human being tendency. That is the human being tendency. That is what the point. So that's why whenever the session is going, I'm requesting everyone to attend the session clearly, completely. Then only you will get the things. Otherwise, definitely you will face the problem in the GATE exam. After the GATE exam, you will be realized. You will be realized. So that's why kindly don't do that mistake. I'm requesting. Clear? Okay. 2-3 people are leaving and coming, means internet issue may be there. Okay, but few people are continuously leaving. I don't know why. That's why I asked, am I clear or not? Right? Okay, now come to this. Sir, measuring lag. Sir, simple definition. Lagging in the measurement. Lagging in the measurement. What does it mean? Lagging in the measurement means in the measuring concept, in the measuring procedure, lagging is there. What do you mean by that? Delay in the measurement. So therefore, what we can say here, delay. But be clear, sir, this is the delay not happened automatically. This is the delay provided intentionally by the manufacturer. Here people are getting confused. Sir, why we need to provide the delay? Delay means unwanted characteristics. No, delay is also the required characteristics only, but delay must be as small as possible. But don't delay. Delay means negative thing. I don't want. No, yeah. Delay is also required. Delay is also required. That too. Wherever the delay is required, wherever the delay is required, whenever the delay is required, right? Then only you need to, what is that? Then only you have to use that correspondingly. Clear? So that's why delay is required in our daily life compulsory. Right? Right. Prajit Tyagi. Yeah. So kindly any fun moment, etc. Okay. Yeah. Actually, my class will be fun here, but starting 1-2 days only, if I started the fun and all, people are thinking that he's explaining only fun. He's in that way. That's why I wanted to bring you all into my track. That's why error analysis chapter, very important. I'm focused only on the subject. After that, fun examples will be there, fun related topic, everything. Subject will be explained in the fun way with fun examples and all. I'll give you, but you need to come into my track first. That's why I'm not taking any fun things so far. But my class will be full of fun. Those who attended my class, they can understand. No need to worry. Right? Okay. Like this, you can share that. No problem. You can share that. No problem. Right, sir. Measuring lag means lagging in the measurement. Lagging in the measurement means delay in the measurement. Delay in the measurement means, what is it? While you are measuring, some delay is happening. That is called as measuring lag. But what is this? This is the delay provided. Actually, measuring lag is not the instrument inherent own characteristic. No, this is the delay provided. This is the delay provided. People are getting problem here, definitely. Sir, why do we provide the delay, sir? Sir, we require as fast as possible. No, why do we provide the delay? Means very simple. The two, delay is not provided everywhere. Delay is to be provided wherever, whenever you require. Simple logic. Sir, I want to add this signal. I want to add this signal. Two signals I want to, that is what my function in the practical idea. Okay, right. Sir, while this signal is coming, it is having some two stages, for example. This stage is taking 1 microsecond. This stage is also taking 1 microsecond. But here, no stages directly coming. But I want to combine these two signals at a time. These two signals at a time. Come on, guys. What is the logic I'm giving here? This is Y, for example. This is X. Y path signal coming here. X path signal, both signal must be combined. That's what our task. Okay. In the task, X is coming, but in the X path, some two stages are there. What are those? I'll tell you later. In the CRO, cathode ray oscilloscope, electronic measurements, I will take it. But example, sir, this signal is passing through these two stages where 1 micro and 1 microseconds of time is being taken. So what is the signal time from here to here? 2 microsecond delay. Therefore, Y signal is coming first X signal is coming after the 2 micro. Can you combine the signals at a time? No. That's why, now tell me, in the Y signal, in the Y path, I need to provide 2 microseconds of time delay. That is what the required. That's why this is the delay provided by the manufacturer wherever, whenever it is required. That is generally provided in which instruments are digital instruments in general. Digital instruments in general, not in the analog instruments. Digital instruments only we are going to provide. Who is going to provide? Manufacturer is going to provide. That's what the point. Clear? That's what that's when you tell me delay is to be provided or not provided. But are you keeping 1 second, 10 second, 20 second, 30 minutes, etc.? No, delay is provided, but as small as possible only. But where means in the digital type of instrument, generally we say. This is one example. One more example I'm giving. One more. Sir, computer is there with you, or mobile phone, etc., almost laptop or something. Simply, you're typing the keyboard. You're typing the keyboard. The moment you are typing the keyboard, that keyboard through that entire process, that entire value should be going to the corresponding path and corresponding decoding, etc., coming to the screen and displayed. Does it take some time or not? Does it take some time or not? Definitely. Therefore, my question is, if you keep on typing that, the process must be one after the other continuously, or all together should be happening, means one after the other continuously only. If all together happening, the system will be hanged up. That's why in your mobile phone also, if all apps are running at a time, the mobile phone will be getting hanged up. That's why one after the other. One after the other means some delay is automatically coming into picture. Yes, that is what called as measuring lag. Delay is to be provided. This is generally provided digital instruments only. This is generally provided in digital instruments only, right? And I'm going to explain clearly with example also. In the CRO, cathode ray oscilloscope, in the electronic measurements, when I take that, I'm going to explain this topic again. But as of now, what is measuring lag? Delay in the measurement. Is it provided or already there? Means provided by the manufacturer. Where means digital instruments. Where it is required, it is to provide. One thing. One more example, simple logic. So our bike is there. Bike is there, right? Because of the application of brake, your journey is getting delayed or not? Yes, because of the application of brakes, your journey is getting delayed. Sir, because of brake, the journey is delayed. I will remove the brake. What happens? Are you getting my point or not? Right? Everyone clear or not? So therefore, what is it here? Yes, brake is required. If you are removing the brake, permanent brake only. Yes or no? So that is the reason why. What is it here? Sir, brake is required. Why means if you want to go from one place to other place to have the safe journey, brake is required. But are you applying the brake for 1 minute, 5 minutes, 10 minutes? No, just fraction of seconds, applying and leaving. So that's why brake is required. That is nothing but delay in your journey is required. Nothing but yes, to have the proper operation only. Here also, I told you same thing. What is that? In the corresponding digital instruments, in the digital instrument, one signal automatically. And one more, the best example is D flip-flop. D flip-flop. Delay flip-flop. Without D flip-flop, can you expect your digital electronic subject completely? Definitely no. Definitely no. So that's why D flip-flop purpose itself is to delay the signal. Why? That is required over there. That is required over there. That is what called as delay. So that's why delay is also required. So don't worry. Clear? Right. Next. Third one is fidelity. Fidelity. Very, very simple. Fidelity means an instrument is said to be having high fidelity. High fidelity means one instrument is having high fidelity. When we should say means when the dynamic errors are minimum. When the errors are minimum, then that instrument is said to be having high fidelity. Means here, this is the degree of an instrument, the degree of an instrument to read, to read without any dynamic error, without any dynamic error. Means, suppose this is the instrument. This is, I want to say this instrument has high fidelity or good fidelity. When can I say? Means in this instrument, dynamic errors are zero ideally, but practically speaking, dynamic errors are minimum. Then we can say this instrument is having high fidelity. That's what the actual terminology. Right? What is it? Instrument is having high fidelity means the instrument is having very less dynamic errors. Then that instrument is called as high fidelity instrument. Nothing but it's a characteristics. Okay. But general doubt, common doubt, very popular doubt is, sir, dead time, dead zone, and measuring lag. Dead time and dead zone, measuring lag, both are same or different? Both are not same. Both are not same. Dead time and dead zone, we are not creating, we are not keeping dead time and dead zone due to the inertia of the pointer. All I told you, due to the inertia of the pointer, means the moment we give the supply, the pointer will take smallest time. That is inherent. We are not creating separately. Any moving body is having its own inertia. That's why this is the inherent characteristic. This is the inherent characteristic. Means for a designed instrument, the pointer is same, pointer weight is same. So therefore, dead time and dead zone will be constant, always same. That's a static. But measuring lag, design instrument to instrument, the measuring lag may be variable. That too, this is the created one. This is a created one. Intentionally, we are providing some delay flip-flop or delay unit like that we are providing. Example, I told you bike brake arrangement like that. That's why these two are not same. This is the inherent characteristic, means its own it is there, but this is the created one. This is the installed one by the manufacturer. But both are required only. Both are required. Clear? Right. Sir, what is a dynamic error? Starting, I told you, error which varies with respect to time is called as dynamic error. Starting day only, I told you. Yes. What is that? Dynamic error means the error which varies with respect to time. That is called as dynamic error. Okay. Right. Now, based on the entire type of characteristics, numericals are there, we have taken numericals, concepts are there, we have taken concepts, everything we have taken. Now, finally, conclusion I'm giving. In all these characteristics, conclusion, concentrate. Sir, among all these characteristics, which are desirable characteristics, which are undesirable characteristics, which are desirable, which are undesirable. But before you answer, I'm giving the point here. What is the meaning of right? Fidelity is under which one? Dynamic characteristics. So that it is based on the dynamic error only, not on the static. Okay, now, sir, desirable means, everyone kindly, those who are on the line, kindly concentrate. Desirable means whatever the characteristic you require. Concentrate, guys. Understand the word, meaning of this word. Desirable means whatever the characteristics you require, higher side, you require better side, you require good side, those are desirable. Undesirable means don't think like unwanted. No, undesirable means whatever the characteristics you require, lower side, poorer side, lesser side, those are called as undesirable. Are you clear the statement? I'm coming again. Desirable means something requires high, something related to good, something related to better, that is called as desirable one. Undesirable means lower side, poorer side, those are called as undesirable. But don't say undesirable means unwanted, I don't want, not like that. Everything is required only. Higher side desirable, lower side is undesirable. Okay, first one, accuracy must be always high accuracy we prefer. So therefore, desirable accuracy. Next we have taken Precision. We need to have high precision. Precision. Okay, next. Drift. Drift means deviation. Deviation must be high or low. Lower side. So therefore, drift here. But don't say drift is unwanted. No, drift will be there definitely, but drift must be as small as possible. Next, hysteresis error. I'm saying not hysteresis topic. Hysteresis error. Error itself is undesirable. Hysteresis error. Okay, next. Linearity. Obviously, we always expect better linear. So therefore, linearity. Sensitivity. High sensitivity we prefer. So therefore, sensitivity. Resolution. Here people are getting confused. Resolution, always we prefer better resolution. Good resolution means as small as possible value says that better resolution, best resolution, good resolution. So therefore, resolution is here. And dead time and dead zone. So dead time and dead zone will be there in every analog instrument, but that must be as small as possible. Suppose if the dead time is like this, do you prefer? If the dead time is like this, do you prefer here? Like this, do you prefer? Means out of this entire input, 90% is waste, only 10% it is responding. No use at all. So therefore, the dead time and dead zone will be there, but as small as possible. Dead time zone. Okay, next. Speed of response. Speed of response must be as high as possible. Speed of response. Next. Now people are getting doubt. Measuring lag. Desirable or undesirable? Kindly let me know. Measuring lag is desirable or undesirable? Measuring lag. Yes. This is what the problem. Yes, this is a general doubt, terminology doubt, sir. 1 second. Come on. Right, sir. Here doubt is this, sir. You told that measuring lag is required. Yes, desirable or undesirable, both are required only. Don't miss this word. Both are required only. But measuring lag must be as small as possible or as high as possible. Measuring lag is as small as possible. So that's why it comes under undesirable. I'm coming again. Many people, I know that many people give that this is coming under which one? Desirable only. Why means, sir, just now you told that it is required. Come on here, all the characteristics are required. Drift is also required. Practically it will be there. Hysteresis error also will be there. Dead time also will be there. Everything. So that is the reason why. What is it here? The corresponding, all the characteristics what we have taken, starting to till low. Accuracy, precision, drift, hysteresis, and then linearity, sensitivity, resolution, dead time and dead zone, speed of response, and measuring lag, finally, fidelity, all are required. But what I told you, whatever the characteristics required for higher side, those are desirable. Suppose if you write desirable, measuring lag, if you write, what does it mean? Measuring lag, you want very high time. Is it delay provided is very large time? No, that is the reason why measuring lag comes under this category. Measuring lag comes under undesirable category. Those who have given desirable, is it clear, guys? Those who have given desirable, is it clear, guys? Right. See, one more doubt. Sir, resolution must be as minimum as possible. Na? Yes, resolution must be as minimum as possible. But what I told you, resolution is minimum means resolution is best. I told you already, resolution is improved. Resolution is improved. Value no here. Here characteristics. Resolution is simple logic here. Resolution is good. What do you mean by the resolution is good? Resolution is good. Resolution is good means your is not the matter. Resolution characteristic means you must be able to measure small value. Then resolution will be good. Yes, that good resolution we prefer. Sai Priya and Namrata. What is it here? Resolution must be good means we measure as small as possible. So therefore, resolution must be always we expect as good resolution only. That's why this is coming under what is it? Desirable only. But only measuring lag comes under this category. Measuring lag here. Finally, fidelity. Fidelity means dynamic error must be low. High fidelity automatically comes over here. This is what the total discussion regarding static and dynamic characteristics. Nothing but what is that error analysis chapter major part with including all the numerical and conceptual questions. Clear, guys? Right. So this is the total discussion regarding entire characteristics, which are to be high, which are to be low. That is what desirable and undesirable topic. Clear? Okay. After this, one more conceptual question. Sir, accuracy and linearity. I'm comparing these two. Sir, among these two, which is essential, which is just desirable? Actually, both are desirable, no problem. Accuracy and linearity, both are desirable. But among these two, which is compulsory, which is based on the condition? Tell me, which is compulsory and which is based on the condition? Govind, because accuracy means value. Speed of response means how it is responding. That is what the point. How can you say both are same? One is static, one is dynamic. Accuracy is compulsory. Few people, linearity is compulsory. Okay, other people, can you respond? Okay, right. Simple logic. I'll give you example, then you can decide. Right, sir. Here, y proportional to x system is there. Y proportional to x square system is there. Sir, in this y proportional x system, if I give x equal to 1, what will I expect for y? 1. Expecting. If I give 2, what I expect? 2. If I give 3, what I expect? 3. Means, are you expecting the accuracy characteristic or not? Yes, expecting. Okay, next. Sir, I'm giving 1. I'm expecting 1. So accurate we are expecting. 2 is given, 2 square, 4 we are expecting. 3 is given, 3 square, 9 we are expecting. So therefore, here also you are expecting accuracy. Okay. Y proportional to sine theta. Theta is equal to 0. We are expecting 0. Theta equal to 45. We are expecting 1 by root. Expecting practically small deviation in the experiment. 90. We are expecting 1. Now tell me whether it is linear or square law or sine law. Any system, are we expecting the accuracy or not? Yes. So therefore, accuracy is essential. Accuracy is essential. Now, sir, in this experiment, do you expect linearity or not? Of course, definitely. But in this system, do you expect linearity? No. In this experiment, do you expect linearity? No. Why? This is the non-linear system. That's why linearity is based on the condition, based on the system. Linear system is the linearity you expect. Non-linear system is there, you cannot expect linearity at all. That's why linearity is desirable. Just means that may be there, may not be there. That depends on the system. That's why linearity is just desirable. Actually, both are desirable, but this is little bit more, nothing but compulsory. This is also very, very, very important in terms of ESC objective question model. So this is the total discussion for today's session. Yeah. But many people give the correct answer, accuracy. Right. Now I'm giving the doubts clarification. Concentrate. People are asking to explain the fidelity again. Fidelity is high means dynamic errors are less. Whenever the dynamic errors are less in that instrument, then that instrument is called as high fidelity. Means fidelity is good. Fidelity is high means errors are low. Which errors? Dynamic errors are low. That's on the point. Right. I explain the fidelity. See, degree of instrument means what, sir? Come on here. That is the quality of the instrument. The quality of the instrument is high when the errors are more. When the errors are more. That's what the point. Suraj Singh, sir, till how much rank AS provide the reward to student? Kindly, that I cannot answer now. Some other persons are there. Right, later on I'll give the numbers. You can contact them. You know AS numbers, right? Office numbers and that you can contact them. I cannot give the clear information regarding that. And many people told that, sir, unmute option is not there. That's why I'm taking typed messages also. Right. Right. I'm explaining why measuring lag is undesirable. Measuring lag must be as small as possible. Measuring lag is as small as possible. That's why the measuring lag is coming under which one here? Undesirable. And one thing you have to follow, undesirable, it does not indicate. Undesirable, it does not indicate, not required. Undesirable means less value should be there, low value should be there, poor value should be there. That is called as undesirable. Right. What if the maximum value is not the FSV? Come on here. They will give maximum value as the FSV. Yeah. The maximum value itself as the FSV. Whatever the value they give, this is 550 to 100, which is the maximum. 100, which is the full scale value. 100. Full scale value itself is the maximum. I'm repeating all I told you. Full scale value itself is the maximum in my entire word. I gave you maximum. No, maximum means itself is full scale value. Full scale value is to be taken as maximum. There is no question like full scale and maximum not equal. No, full scale value is treated as maximum. That's what the point. Range is also full scale value, sir. Yes. Right. Saujanya, good question. So how can you say accuracy is essential? I have compared with the linearity. Then accuracy is essential. That's what the point. IFSD means, see, 0 to 10 ampere ammeter is there. IFSD, full scale deflection. How much are 10? So 10 is the IFSD. That is 10. Right. Right. See, one student is saying that 0.000102 mega ohm. Sir, how are you writing 102 ohm? I am not understanding. Sir, mega, yeah, 0.000102 into 10 power 6 ohm. These many digits are there. What is it? 102 into 10 power minus 6 into 10 power 6 ohm. That is equal to 102. That only I have written. Clear? Thanks. Alan Matthew. Sir, full scale value is 200 and calibrated from 5 to 100. How can you say that? No way. If you're calibrating from one range to other range, whatever the highest range is there, that should be the full scale value of the device. Come on here. You are saying like this, this is 0, this is 100. Whatever the highest scale value is there, whatever the maximum value is there, that is what full scale. Full scale something, maximum something will not be there here, will not be there. What is it? Whatever you are designing, what do you mean by that? Can you go more than 100 here? Can you go more than 100? No, means it is maximum. It is full scale value. Kindly get the terminology, right? Full scale value is 200. You are asking like this, sir, I'm having 0 to 200, but I'm calibrating from here to here only. Means, be clear, while you are calibrating, one must be reference. Which one is reference? Full scale value, generally reference will be taken. That's why whatever the calibration highest value is there, that itself is the full scale value. So be clear. Range is also called as full scale value. Range, full scale value, full scale deflection, everything is same. Right. Between accuracy and precision, which is essential, both are equally good. Both are equally essential. Both are equally essential. Right. Abhinesh, range is always maximum. Yes, range is always maximum. Range is always full scale value. No problem. Right. Jitendra, sir, why linearity is a static characteristic? It should be dependent on dynamic error also. How? How dynamic error? How dynamic it is dependent? Jitendra Latwal, tell me. Right. Mridil Sharma, sensitivity formula understood, but numerical, I was lost, means nets of problem, etc. No problem. Recorded video is there, you can watch it, you will get it, no problem. No worries, no worries. Right. Right. Dead time, very good question. Rutuja, right? Dead time is generated only in analog instrument. Yes, I mentioned already. Dead time will be there only in moving object. That is analog instruments only. Analog instruments only. Right. Tulasi. Right. Here, sir. 0.000102 ohm is there. 0.000102 ohm is there. This is 102 ohm, 102.0 ohm. Then we cannot comment the precision because this is 102 value. It is also 102 value, but this is 0.000102 value. You cannot comment the precision. That's why I told you, in order to comment the precision, you should have the equal weightage. This is 102 rupees. This is also 102 rupees, but this is 0.000102 rupees, not 102 rupees. We cannot comment the precision. Okay, but if you want to write separately significant figure, we can write. What is it? Here, left side, decimal point is there. You need to, which one here? Start from the left side. Yes, cancelled. Significant 3. But sir, this is 3, this is 4, this is also 3. No, you cannot compare. This is 3, correct, but you cannot compare. When weight is different, you cannot compare. Weight is different, you cannot compare. That's why if you want to write separately, you can write any number. You take any number, you can write significant figures. But if you want to comment on the precision, the mathematical weightage must be same. Right? Right. And Dinesh, okay, I'll solve that question. See, sir, I'm facing the problem in solving means today only topic is done. After the class, practice my entire class notes. Then you will get the idea. Then you will get the confidence. Then you will solve all the questions. Don't have any inferiority complex on yourself. Kindly don't lose self-confidence. Today only we have started. Today only we have started the numericals. Today only I solved the numericals on the sensitivity and all. That's why after the class, take the entire notes, practice those questions again and again. Then you will get the confidence. Don't have the negative thought, I'm requesting. Because the starting stage, no, don't have the negative thought on you, definitely. Right. Next, one more question. Don't send the message 2 to 3 times, all I told you. Right. See, Mandala Ashwini, you are telling dead time is constant. Those constant is used for analog or digital ones, sir. All I told you, dead time or dead zone. Just now also I told you, dead time and dead zone are only for analog instruments, not for digital instruments. In the digital instruments, delay we provide separately. Dead time, dead zone is the inherent characteristic. Already inbuilt in the instrument, it is there. But delay is there in the digital. Both are different. Both are different. Don't combine kindly. Constant value are for digital one, sir. Who told constant values are digital? As constant value are for digital one, sir. Who told constant value is digital? Come on. See, in the digital instruments, we provide the delay. Intentionally, we provide the delay. But in the instrument, analog instruments, what is it? Dead time and dead zone already there. Already there. And that too. Here, I'm clarifying doubt. Sir, in the instrument, suppose I'm taking a instrument, this dead time is always constant because in the A instrument, dead time is always constant because pointer is same, material is same, you're not changing. Therefore, dead time is constant. That's why it is coming under static characteristics. But people are getting, sir, delay. Sir, what is delay? Right? Delay means measuring lag. Simple, you are missing small point. Sir, why it is dynamic? It is constant, no, constant. Sir, here, suppose, here, I told you, no, Y line is coming. Here, X line, some stages are there. Here, you are combining like this. Suppose, I want to add X plus Y. I want to add X plus Y. Sir, this is the 1 nanosecond. Here, 2 nanoseconds you are there. Sir, X is given 2. X is given 2, right? Y is given 1. 2 plus 1, 3. Are you clear? Now tell me, because of this delay, the output value is always constant or always variable? Always constant or always variable means for that I'm giving clarity here. Sir, I am taking X plus Y. Simple logic. Sir, this is X input. This is also X input. This is Y input, for example. X input, X input, Y input. Sir, my output is X plus Y. Okay. Sir, it is having only one input port, one input X, but two sides you're sending. That's why assume that for this operation, 30 microseconds will be there, for example. For this operation, 30 microseconds will be there. Okay, right, sir. Here you are sending this, right? You are sending this. So let me take this as X1, this as X2, for example. Okay, sir, at the first time, what you are sending? X1 plus Y. So therefore, this will be delayed with 30 microsecond. So that 30 microsecond, it will be delayed. Then X1 plus Y will be added. Yes, X1 plus Y, something 5 or something will be there. Okay. Immediately, the next 30 microseconds after that, it is ready. Then it will be provided by next 30 microseconds of delay. Then which will be coming? X2 plus Y. Earlier X1 plus Y. Now X2 plus Y. Output is varied or not? Output is varied. Therefore, due to the delay, listen carefully, due to the delay, output characteristic, output values are changing. That's why the delay, the measuring lag is called as dynamic characteristics. But 30 is the value, okay. But due to this 30, what is the behavior? That is what? the dynamic. So that's why once x plus 1, x1 plus y, next x2 plus y, next x1 plus y, next x2 plus y. Therefore, the values keep on getting changed. That's why the measuring lag comes under which category here? Dynamic characteristic category. Right. 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 Mahinder Prasad, right. If the instrument is provided with high sensitivity, yes, the reading will be accurate. Reading will be accurate. Means high sensitivity means small changes there, it will show properly. Therefore, that is under 2. Nowadays, every people are taking oximeter. It must be high sensitivity. Why? 98, 92, 93, 93.5. It has to show means, yes, it is having high accuracy. No problem. And जितेंद्र लतवाल, kindly try to understand. मुझे मेरा बात सोचने को ट्राई कीजिए kindly, right? कोशिश कीजिए. Don't type one message for many number of times so that I'll be missing some other people doubt, right? I already you told that, sir, unmute me. You told no, I will unmute. Let me explain. Don't be that much over enthusiastic, right? Now you can speak.
Hello.
Yeah.
Good evening, sir. Sir, I'm saying that if linearity you are saying is depending on static error only, then
Who told? Did I say that statement?
sir, but it's a static
No.
character.
Did I say that statement?
No, sir.
Then you don't say you said, right? Okay, now tell me.
Sir, if it is a static characteristic, so should it not be implied that it's depending on static error?
Your question, you asked the question.
So this is the question, that if it is implied that it is a static error, then in the dynamic conditions, when dynamic error will come and the system which we assumed in static conditions that it was linear, in dynamic it is not linear, then what is the use of such a system that in dynamic conditions it is not linear? So should this linearity be a dynamic condition? No, that it should depend on dynamic error also. If in dynamic conditions also it is linear, then we should say that finally the system is linear.
Okay, right. If I say, sir, static error, I'm saying that AM minus AT equal to plus or minus 0.1. Is it constant or variable?
The, it is constant error, sir.
Constant, right? But
Yes.
according to your answer, sir, due to the dynamic changes and all, as the AM is changing, the value is changing. No, means there is no static. You are saying that only you are saying, right?
Yes, sir. So in practical conditions, it will not be static. It will be
So
dynamic.
therefore, in the practical condition, there is no static error at all. You are saying, right?
No, static error is there, but dynamic also there with it.
That's what I told you, right? That's what I told you. When do you take static means you're missing small point. When do you say static means for a given particular condition, for a given particular operation, you know, question only answer is there. So dynamic changes are there means what is that? At a particular room temperature, at a particular given condition, at a particular given input, the nature is constant. That is called as simply, what is it? Static characteristic we say. Even though it is changing, that is dynamic. But in your question only, what is it? Sir, under dynamic normal practical conditions. But my point is static means for a given conditions, for a given atmospheric conditions, for a given environmental conditions, those are constant. But dynamic means whatever the condition you take, those are keep on getting changed. Those are called as dynamic. Then dynamic errors are irregularly keep on getting changed. But static means for a given condition. That's why concentrate. Once a system is designed, suppose this instrument is taken, right? Suppose this input, right? This is the output. In particular temperature condition, I'm increasing from 0 to 1, right? Output is also increased from 0 to 1 and 1 to 2. Output is also increased from 1 to 2. Means the change in input, change in output is same. Means for a particular change in input, this much of particular change in output is there in that corresponding construction, in that corresponding given condition. That's why this is called as linear coming under static.
Sir, but
Okay.
if
According to your answer, I'm coming. According to your answer, sir, if the conditions are changed, obviously, if the conditions are changed, means there is no question of static at all in the practical world.
yes, sir.
Is it no?
Sir, if we
That's
are
right.
taking this thing into account that in dynamic also we are working at a particular condition, then sir, dynamic characteristics should not exist only because those also they will exist at a particular condition only. You know, sir,
See,
they should
at a,
also
pa-
be static.
very good. At a particular temperature, at a particular condition, 0, 1, 2 is there. Right? 0 to 1 means 0 to 1 change is there. Suppose if it is 1 to 2 change is given as the input, but it is giving 1 to 3 change, then that is called as junior dynamic characteristics.
Sir, can you please repeat this last point
See,
again?
for a given input 0 to 1 change, output change is also 0 to 1. 1 to 2 change, but output changes 1 to 3 is there. 1 to 3 means input change, output change is not same, even for a given condition. Therefore, behavior is changing. 0 to 1, one behavior, 1 to 2, other behavior. If that is there, then that is called as dynamic.
Okay, sir.
Are you getting?
Yes, sir.
That's why your thought is good, but small, what we say, thin line is there. For a given condition, if the behavior is same, static, for a given condition or different condition, anything, if the behavior is different, that is dynamic, simply.
Okay, sir.
Right.
Thank you, sir.
Right. Right. Sir, Puttana Sai Praneeth, right? That is parallel combination here. I will solve that parallel combination later. At the end of this chapter, I'll solve that. No need to worry. Right. And sir, in the thermo already I told this. Prasad Pedapati, right? I answered this. Measuring lag is provided by manufacturers, so the value may be anything now. So how can we say that undesirable cat? See, very good question. Manufacturer will provide the delay, but generally that delay is very, 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 very small in the operation. Otherwise, the instrument main operation will be disturbed. That's why digital instruments are faster or slower. Faster means digital instruments are faster, but in that I want to provide the delay means that must be small value. As it is small, this is undesirable. I did not say as it is provided manufacturer. No, you're missing small thing. I'm coming again. See, you're not understanding the point. Desirable, undesirable means desirable, whatever the things we have written, no, those are high or good, those are desirable. And you're missing one more thing, sir. Undesirable means I'm not saying that unwanted. Whichever required are low side, whatever the characteristics required are lower side, those are undesirable. Small value of delay, that's why I have written delay here. Pranali, clear? Right? You're missing small thing. Undesirable means it is not unwanted. Undesirable means it is required, but lower side required. That technical word is undesirable. That's it. Right. Vaishnavi, we cannot say that comparison precision. No, exactly. Mathematical value should be same. Definitely. Okay. Vaishnavi, clear? Right. Okay. Jayalakshmi, one second. 219.029, 219.0. Right. 219.029, 219.0. See one thing here. If the mathematical weightage is same, no second thought at all. Go to the procedure. In this 3, in this, your decimal point is there. Yes, neglect this one. 3, 3, 4. So which is highly precise here? This is highly precise. That's why in the hurry mode, don't take different examples after the class. Leisurely take the notes, take some example number, mathematical weightage is same, take that and see that notes. Okay, then you analyze, you will get it. You will get it. Right. Sir, how drift is related with instrument? That is experimental setup. I told you machine is required, corresponding instrument is required. In the machine, as you're changing the input, the instrument is giving some values. Expected is this, given by that is something else. That is experimental analysis based, means some machine, some structure is required. Gnaneshwari, not Ganeshwari, not only the device, it requires with respect to the combination, but our topic is instrument is giving so and so. That's why I'm calling this as instrument character. That's it. Right. Still people are raising the hand. Anyone? Right. No one is there. So many typed questions I answered. Okay. Vishnu. Hello?
Sir, it is that regarding that voltmeter question only, sir. That 3 voltmeters you solved, no? One question.
Regarding 3 voltmeter question.
That they are that.
Yeah.
This one, sir. Here, like what you solved previously, that I understood, sir. That is okay. But initially, when I tried to solve on my own, this voltmeter V2, when I tried to calculate the current, it came around 4 milliamperes.
V2 current.
Yes, sir. This no, I took the inverse, the maximum full scale deflection, that inverse I took. I got 4 milliamperes as current.
Okay.
So then, based on how you explained the previous question, the V2 had 4 milliampere, V3 has 100, and V1 has 5 milliampere. So obviously, it will allow only the current that V2 can allow maximum permit.
V2 4 milli, you got it. Okay. Tell me,
Yes,
V1?
V1 is 5, that is already there.
Okay.
And
This one?
V3 is also 100, it is there.
Yes.
So in this only 4 milliampere can flow, because V2 will only permit.
One second. You're missing something. This 4 milliamperes, in order to flow that, we have calculated how much voltage is required. But here 120 volts is already given. With this 120 volt, how can you give the guarantee that 4 milliamperes is flowing?
Oh, okay, sir. Correct.
Got it?
When I calculated also equivalent current also, it came around 2.5. So that's what it made some cut.
Yeah, that's what. See, in that question, voltage was not known. For corresponding to that current, we have calculated the voltage. But here voltage is given. No, you cannot take like that. Okay?
All right, sir. Thank you, sir. Thank you very much.
Very good. Right. Mubin.
Hello.
Yeah, tell me.
Thank you very much, sir, for unmuting. So first of all, your lectures are very good, sir. It's very
Thank you so much.
Yeah, sir. That in resolution we solved two problems now, sir. One tenth of the scale division can be estimated with 5 degree. That question, this one only, sir.
Yeah.
Sir, please explain that underlying statement, sir. I mean, how to relate to this equation.
Simple logic. Yeah, 1 second. Simple logic. Yeah. See, one instrument is there. 0, 1, 2, 3, 4, 5. Okay, 5 amperes are there. How many divisions are there? 5 divisions are there. Okay, what is the smallest measurable value? 5 ampere by 5. What is the value? 1 ampere is the minimum.
Ampere.
Okay, right. In this question, what I'm giving, 1/5 of division. 1/5 of each division can be estimated with a fair degree of accuracy. Means in these divisions are not there, but according to the given question, 1, 2, 3, 4, 5, 1/5 he is able to measure. Means this much he is able to measure as the smallest value.
Okay.
Right. So therefore, What is the point now? What is resolution? Means total is 5 amperes, but this is not the smallest measurable. According to the question, this is the smallest measurable. Why? 1/5 of the division. Some other number I'm taking. If you take 1/10, it will be looking repetition. That's a 1/5. Means in one division, fifth part is able to measure. In one division, fifth part is able to measure. Means in this 5 divisions are there, 5 subdivisions are there. Therefore, here 5, like this, 5 divisions are there. Now tell me how many smallest possible divisions are there totally?
Now 5 into 5 is 25.
Yes, that only I've taken. That's it.
Okay.
Now go back.
Yes, sir. Sir, done, sir. Sir, one more, sir. You have one of the student asked about this question 2190219.
Yeah.
Sir, in that 0219 significant figure is 4, na, sir. You have cut at the left hand 0.
Oh, sorry. I thought it is decimal point is there.
Okay.
One second. 2190219 and what more value?
0219.0.
Yeah. I thought it is decimal point is there. Here decimal point is not there. 3. Sorry, yeah. Here decimal point is not there. 4. Here decimal point is there. What you have to cancel? This one. Sorry, I have taken the reverse way. This is 4. Is it your doubt?
No, that's I'm just clarifying that.
Yeah, actually I have in the reverse we have written. Yes, correct.
Yes, sir. Sir, why we are going for this significant figure, sir? I mean, weightage is same, everything is same.
Actually, you will understand the better way when I start the digital voltmeter. Simple logic here. In the digital voltmeter, 3-digit DVM is there, for example, right? 100, for example. If I take 4-digit DVM, we can get 100.0, 100.2, 100.3. It means if one digit is extra, clarity is more or less? More. That is what significant figure also coming into that way only. That's why based on the number of divisions we are going to get that. Means which is giving better information. For that purpose, significant figure is being taken. 219 is there. We don't know next digit allowed or not. We don't know. But 219.0 means yes, next digit is allowed. In that way, we are going to take. But other than this, I'll explain rest of the topic in the digital voltmeter.
Okay, sir. Sir, one more. Sir, one of another friend asked that if there is high resolution, then what comment on accuracy? I mean, the similar statement is there, sir. If we have high resolution, sir, what would be accuracy?
Asking the question or answering?
I'm asking, sir. Just you answered it, but I want to again hear it from.
Very simple. High resolution is there means smallest values we are able to measure. Yes. As you are measuring smallest value means 1.9 or 1.91. Small value. Small change also measured. 1.915 like that. Smallest values are able to measure means automatically accuracy will be good only. Yes. Among these two, for 2 amperes of supply, for example, which is highly accurate?
915.
Where you have more resolution? After the decimal 0, 0, only 2 decimal.
Second one.
Yeah, that's very simple. Simple logic I'm giving here. Those are on the line. High resolution, high accuracy, high sensitivity, all together operated always. Generally.
Okay.
Simple. Over.
Sir, okay, sir. Last one, sir.
Yeah.
Sir, this fidelity we have explained in that you have said that less dynamic errors, high fidelity, more dynamic errors, low fidelity. Yeah. But that less means magnitude of error or number of errors, sir?
No, magnitude only. Means, see, large variation irregular is there. Dynamic, for example, poor dynamic. If that variation is very small, means magnitude is very, very small. So simply good fidelity in that.
Okay. One more thing, sir. That dynamic error is only a single error, or it we have any subcategories, sir?
No, dynamic errors are how do we analyze it? I'll tell you. So many categories are there. I'll tell you. That is the next topic tomorrow. Random error analysis is there. I'll tell you later.
Thank you very much, sir.
Nice.
Hello, sir.
Yeah, tell me.
సార్ సిస్టమ్ కి లీనియర్ క్యారెక్టరిస్టిక్స్ ఉంటే అది ఓన్లీ స్టాటిక్ ఎర్రర్ ఉంటది ఆ సిస్టమ్ లో అని చెప్పొచ్చా సార్? అండ్ నాన్ లీనియారిటీ క్యారెక్టర్ అది నాన్ లీనియారిటీ ఉంటే ఆ సిస్టమ్ కి నేచర్ ఓన్లీ డైనమిక్ ఎర్రరే ఉంటుంది అలా చెప్పొచ్చా సార్?
అంటే జనరల్ గా అనొచ్చు, బట్ లీనియారిటీ నాన్ లీనియర్ డిఫైన్ చేస్తున్నప్పుడు ఎర్రర్ లాగా డిఫైన్ చేయకండి, సరిపోతుంది. లీనియర్ ఉంది అంటేనే ఓకే, కాన్స్టెంట్ లైన్ వెళ్ళిపోతుంది, స్లోప్ లైన్, సో స్టాటిక్ ఎందుకు వస్తుంది. బట్ నాన్ లీనియారిటీని కూడా లీనియర్ తో కంపేర్ చేస్తేనే మీకు నాన్ లీనియారిటీ ఉందో తెలుస్తుంది, అవునా? ఇప్పుడు ఒక సిస్టమ్ ఉంది, దాని నాన్ లీనియారిటీ ఎంత ఉంది అని తెలియాలంటే మీరు లీనియర్ సిస్టమ్ తో కంపేర్ చేయాల్సిందే కదా. అందుకని దాన్ని డైనమిక్ ఎర్రర్ అనకుండా వేరీ అవుతుంది, జిగ్జాగ్ వేరియేషన్ అంటారు అనమాట. కాకపోతే ఒక పర్టికులర్ సిస్టమ్ కి అది సేమ్ నాన్ లీనియారిటీ వస్తుంది ఎప్పుడు, అందుకని దాన్ని స్టాటిక్ లో చదువుతాం అంతే. లేదంటే మీరు అన్నట్టు డైనమిక్ లాగా చెప్పవచ్చు, ప్రాబ్లం లేదు.
ఓకే సార్.
Hello, sir.
Yeah, Shiva. Tell me.
Sir, good evening. Sir, in 10F, sir.
Hello?
Sir, in 10, page number 10F, sir.
Page number?
10F, sir.
Yes.
Sir, here, I don't get that operation region towards FSV, sir. Could you explain it one more time, sir?
Little bit louder. I'm not able to listen your voice.
No, sir. The operating region you wrote, sir, towards FSV.
Did you attend yesterday's class?
Yes, sir.
What I told you, operating means if any scale is given, if you are going towards the full scale value, the error will be
minimized.
Error will be
minimized.
So if the error is getting minimized, you prefer that as the best operating region, or error is more, you prefer that as the best operating region.
Oh, okay, sir. Okay, sir. Got it.
That's what the point. Got it?
Yes, sir. Sir, and 12F, sir.
12F. Okay. 12F, it is rough only. Nothing is in the 12F.
Oh, okay. Sorry, sir. 16F, sir.
Yeah. What is there?
I missed something. It is regarding the dead zone, I think. Sir. I got clear with the doubts.
Okay. Thank you.
Yes, sir. Thank you.
Sir,
Yeah,
good evening, sir.
Yeah, good evening.
Sir, once explain 17F problem, sir.
17F problem. Right. Here, sensitivity is given. Sensitivity is there, IFSD you can calculate. Okay. Sensitivity is there, IFSD you can calculate. After getting IFSD, VFSD is there, IFSD is there, resistance. VFSD is there, IFSD is there, resistance. Okay, leave it. Next, what he is asking, maximum voltage which we can measure with this combination means, what is this maximum? In order to measure the maximum voltage, maximum current we have to calculate, because resistance already constant given for a device resistance will be constant. Therefore, I maximum. So which is the I maximum can be allowed through the circuit means 0.1 its capacity, 0.05 its capacity. Now tell me, this can carry up to 0.1 milli. This can carry up to only 0.05 milli. Now, how much current can be allowed? How much maximum current can be allowed through this combination? Means 0.05 only. That only I gave you clearly by explaining different combinations like this. Therefore, in the series combination, minimum capacity will be the maximum allowed current. That's why 0.05 milli into corresponding value. That's it. Nothing more than that.
Okay, sir. Thank you, sir.
Sai Charan, unmute. You raise the hand.
Hello, sir.
Yeah, tell me. Yeah, tell me.
Sir, fidelity will explain about the dynamic error, but in order to synchronize with the static error, can we say that static error will have high fidelity or maximum fidelity?
Only dynamic error. Fidelity means only dynamic. Static error, no.
Okay, sir.
If
Ah.
dynamic errors are low, fidelity is good. Fidelity is the topic with respect to only dynamic nature, not related to static nature.
Okay, sir.
Clear?
Yes, sir. Sir, generally, how many times we should revise a subject such that we will get a good grip on a subject, sir?
Very good. Good question. ఇప్పటికి చాలా మంది ఒక గుడ్ క్వశ్చన్ అడిగారు. జనరలీ సి మీరు నేను క్లాస్ చెప్తున్నప్పుడు ఒకసారి వింటారు, అవునా? అంటే మీరు వింటారు, కొందరు వినలేదు, అది పక్కన పెట్టండి. మీరు వింటున్నారు, ఓకే, రైట్. అయితే క్లాస్ అయిపోయిన తర్వాత వెంటనే ఈ రోజు కానీ రేపు కానీ మీరు రివైజ్ చేస్తున్నారు, అవునా?
ఎస్ సార్.
అలా సబ్జెక్ట్స్ అన్ని అయిపోయి కొన్ని నవంబర్కు డిసెంబర్కు మా సిలబస్ అంతా అయిపోతే అప్పటి వరకు మీకు సబ్జెక్ట్స్ అన్ని ఒకసారి అయిపోవాలి. ఎప్పటి వరకు? నవంబర్ వరకు అయిపోవాలి. డిసెంబర్ మంత్ లో ఒకసారి, జనవరి మంత్ లో, అంటే మీరు నార్మల్ ప్రిపరేషన్ కాకుండా 2 సార్లు కంపల్సరీ రివైజ్ చేస్తే డెఫినెట్ గా సింగిల్ డిజిట్ ర్యాంక్ ఎక్కడికి పోదు, డెఫినెట్ గా వచ్చేస్తుంది 2 టైమ్స్ పక్కాగా. బట్ ఈ నవంబర్ వరకు మీరు షెడ్యూల్ పక్కగా ప్లాన్ చేసుకొని ఇంకొకసారి రివైజ్ కూడా చేసుకోవచ్చు. బట్ ఐడియల్ కేసులో ఏం చెప్తున్నానంటే డిసెంబర్ జనవరి కంప్లీట్ రివిజన్, అంటే నవంబర్ 30 వరకు మీరు సిలబస్ అంతా కంప్లీట్ అయిపోయి ఉండాలి ప్రిపరేషన్ లో. అది పాయింట్.
Okay, sir. Sir, similarly, what about practice questions, sir? Like, when do we do practice questions like that, sir? When to take a test series?
అయితే మీకు సబ్జెక్ట్ అయిపోయిన తర్వాత ఎగ్జామ్ పెడతారు, అప్పుడు మీరు ఎగ్జామ్స్ రాస్తా ఉండొచ్చు. అంటే మీరు ఒక సబ్జెక్ట్ అయిపోగానే ఎగ్జామ్స్ పెడుతుంటారండి. ఆ టెస్ట్ రాస్తా సబ్జెక్ట్ వైజ్ ఎగ్జామ్స్ రాస్తా పోండి కంటిన్యూస్ గా. ఎప్పుడు కూడా ఎగ్జామ్స్ కంటిన్యూస్ గా రాస్తేనే మీకు సబ్జెక్ట్ టచ్ లో ఉంటుంది.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Anil Kumar.
Sir, good evening, sir.
Yeah.
Sir, in 29F.
29F. Okay. Yeah, tell me. Oh, 29F means, yeah, this one. Is
sir,
it?
Sir, problem, sir, before problem. The
Problem.
Coil. Yes, sir.
Either?
1/10. Yes, sir. Sir, I have understood.
ఇప్పుడే చెప్పాను. ఒక స్టూడెంట్ కి ఇప్పుడే రివైజ్ చేశాను. అప్పుడు ఒక 2-3 సార్లు చెప్పాను, మళ్ళీ ఇప్పుడే చెప్పాను. వినలేదు మీరు ఇంత?
Sir, can you please explain in English, sir? I did not know Hindi.
Yes.
Hindi, sir. I am from Tamil Nadu, sir.
You are not Telugu?
No, sir.
Okay, no. Just now I explained to one student here. Just now I explained this topic in the doubt session only. Didn't you listen that?
Yes, sir, I have listened it, sir, but I did not get clearly, sir.
What is your doubt? That tell me the point of doubt.
Yes, sir, I have understood that the full scale reading is 200. From it 100 division means calculating for one division for one line, how many divisions I have calculated, sir. And they mentioned that 1/10 of a scale division can be estimated. That line, sir, I did not
see. Each division value, how much you got?
So each division value I got 2, sir.
2. In one division, how much value he is measuring?
So one division is 2, sir.
In one division, how much value he is measuring? 1/10 of the division, right?
Yes, sir. One right? Division. Okay,
one division is 2 volt. What is the 1/10 of the division? Simple logic. One division, 2 volt. What is the 1/10 of the division? Dash. How much value? 0.2 volt. That's it. That only I have done.
Okay.
See, one division value, up to that you got it. But in one division equal to 2 volt. In that 2 volt, 10th part he is measuring. 2/10 in 2. What is the 10th part here?
0.5.
Come on.
0.5, sir.
Huh?
0.5.
0.5. Come on here.
0.2, sir. 0.2.
0.2. Yes, that's what I told you. That's it.
Okay.
Okay then. I clarified all the people doubts, it seems. Right. I'm closing the session. Kindly practice.
Sir.
Right. Who is this?
Sir, this is Muhammad Naveen. Sir, a small request, sir. Sir, yeah. After every class, please give an unsolved question. Only one, sir. So
definitely.
We will Only one.
Definitely. Actually, yeah, Mubin, very good. Actually, that is what my way. Don't worry. Actually, let me complete the chapter first.
Okay.
So starting chapter, definitely every day 1 or 2 homework questions, either conceptual or numerical, will be given definitely.
Yeah, thank you very much,
Definitely.
sir.
That is what my way. Definitely, I'll give you. But if this topic is done, people will come into my track. Then I can. That's what the point.
Yes, sir. Thank you very much.
Right.